So welcome everyone to the Forth 2020 Zoom meeting in April 2022. So we have a very good schedule of talks today. And so let's see, without further ado, Scott McCallum wants to talk about his force to the power of 3. And give us some demonstration. So, Scott, are you ready to present?
I do believe so.
Yeah, then please share your screen so that we can see it. Yeah, we see some green, large and small letters. The stage is yours.
Rightio then. Well, my name's Scott McCallum. I'm actually a software developer coming up for probably 40 years now. So I got started when I was 8 and we sort of hit the big 50 this year. I've always had an interest in programming, and for the last 25 years, I've been working for myself with an enterprise product to manage disk space. But over the last 5 years, I've been sort of in a bit of a pivoting mode, and I'm building an asset exchange. So an asset exchange that can exchange non-fungible assets. So things like movie tickets and doctor's appointments and other types of things that have a heap of properties associated with them. So the reason I'm investigating forths is that I needed a sandboxable language that you would actually write your orders in. So you might be familiar with a stock exchange where you basically say, this is the stock code I want, this is the price, and this is the quantity. And generally, you've then got a small series of other properties that you can go along with it. But it's not programmable in any sense. So I'm building a system where the buy and sell orders are forth programs. And these forth programs, in effect, are sorted, and they actually figure out whether the thing that you're purchasing is available, can I get it for the price I want? And if so, it actually makes it happen. This thing is being developed in Python. And so I ended up looking around for forths that run under Python. And the only other major one that I came across was RetroForth, which is available in a whole heap of platforms. Because RetroForth is at its core, its cells are integers. It's a sort of, there's a bit of an impedance mismatch between Python and RetroForth. RetroForth works, but Python, it just sees crazy numbers all over the place. You can't take advantage of the Python objects. So I ended up embarking on developing my own forth, and I called it CubeForth. And in CubeForth, the cells are actually Python objects. So I can go across and type something like hello world and put a plus at the end of that, and it's concatenated 2 strings for me. So it's nice that things like string management are really quite simple to actually work with RetroForth. It's got a mode where it actually understands JSON. So Scott was here. That also works. Now that looks like a comment, but basically where the next character after an open brace is either a quote or it is a brace, you can actually start putting in JSON structures, which is handy because I need to be able to match against these structures. So that will actually create a Python dictionary on the stack. So I've got a couple of, I've basically listed a whole heap of these commands that I think are interesting in the forth, and I'm just going to run through a couple of them. So we've seen the string uses that single quote as it's starting off, which is what RetroForth used. I've also got in there the ability to do multi-line strings. 1, 2, 3, 4, and close that string off. And you can actually see there that the string's got a carriage return character in it. So it actually supports multi-line strings, because if you do any sort of Python work, multi-line strings are just natural. And I'm basically building up bigger things with this. So that's the multi-line strings working. If I get rid of the things off the stack, oops, excuse my, so at the moment, if it gets an error, it actually brings the exception all the way up just for debugging purposes. Because this is an object, I can, again, using the, if it's a brace and a dot, it actually says, okay, you want to call a method on the object, on the stack. So I can go replace, and I'm going to replace L with X. And you can do string matching type stuff. And this really means that the speed of the Python interpreter, because we're dealing with native Python objects, is actually really, really fast. It's very performant. Some of the raw tests put it as an equal speed to RetroForth for simple things. But as soon as you start getting more complex stuff, it really comes into its own. So I can do things like with my string here, 1 cat 2. So that's a string, 1 cat 2. I've got JSON load, and it didn't like that. Where are we? 1 cat 2. I didn't close that dictionary list off. So that's given me a Python dictionary. Because memory in this thing is actually a Python dictionary, I can actually say foo bar and actually go store that in memory. If I type mem, my memory, as far as the memory of the system is concerned, it's dictionary. I can actually use strings or I can use integers with this. So it has all the standard here type notations for memory and growing memory and that sort of thing. But I'm finding with the programs that I'm writing with CubeForth, I don't tend to use the forth variable declarations. I just store them directly in the dictionary under the variable strings, which is handy for that. Memory, so we've seen memory. If I do things like C here, and C shows you the definitions of the words, it actually comes back with the underlying Python implementation and gives you the actual Python bytecodes that represent that method. It's interesting because the actual words are defined in the, where are we? The words are defined. So here's the, so we've got word T left brace. So it actually uses Python introspection of the method names to actually figure out what is the actual underlying forth name for that thing. So I've got T brace exclamation mark, which was basically doing knots and things like that. So I'm playing around with some of these things. But there's basically, we've got words. So it's a fairly complete implementation. I've got it down so there's probably half a dozen tests that aren't currently working, and the tests, stop, tests. So it's using that the John Hayes testing library. And there's certainly some things that I don't need to test, and that's particularly got to do with the integer support. Because if you do crazy things like 232 to the power of, you get your 4096. So if you only had basic integers, then that's you know, where they start to top out. But we can go 4096. Because it uses the Python infinite precision number libraries, which basically means that, yeah, you can go to town on these things. I've actually, in the sandbox, got to put restrictions on the numbers because you can basically create crazy numbers and crash the sandbox on that side. So I've got to put some controls on just how crazy you can go with those numbers. Because clearly it's quite easy to raise that to itself, and all of a sudden you've got a 1,000,000-digit number coming out of Python, which is sort of interesting. It supports things like 5 plus for J, minus 1 J, and add them together. And we can see over there we've got 4 plus 3J, so it supports the complex numbers as well. And again, this is all freebies that you get out of Python as an underlying object system, which is handy. So I've got things like, I had my JSON load up here somewhere, JSON load. I can do things like do v print it loop.
That loads
Oh,
it.
no, I've forgotten the
close square
the
bracket.
close brace. So that's actually looped over the things. So again, that supports the Python iteration type of objects, which is handy. I can also do interesting things like this, which is say x times 3, t times 3, and that's lambda, LAMBDA. So if we go c times 3, that's actually a Python function. So I can go 3 times 3, and I get 9 back. So it's quite handy. So you can actually just put little Python snippets in there. So you don't need to always go into the actual interpreter. Now in the sandbox, clearly it's not going to allow things like lambdas to come out of it. You can also do things like, if we do our double strings, def word foobar, and it takes 3 parameters, and 1, 2, 3, 4, return foobar, and that close the string off, and say that's Python. Okay, so now if I do foobar, I should get back a capital foobar. So you can basically define blocks of Python code and actually turn them into a function and then manipulate them in Forth, which is handy. So things like if I do, it's single quote and then times 3, that actually brings up the that's the execution token as far as this thing's concerned. It's a Python tuple with a function pointer in it. So I can then go 3, well, no, we'll go 33 swap and 33 swap and execute. I get 99. So it basically, yeah, so the quote pulls the execution token off, executes it, but it's just as if I had have written as 1, 2, 3. And if I want to see Baz, I see Baz, I get 1, 2, 3. The execution token for Baz is actually just a list. So you can actually create your own functions in code and actually make them run if you like. And I had one more demo. What is it? So by doing the, how am I going for time? I've got 3 minutes. All right. Hello world. So that will create me a dictionary on the stack. I can then go world, no, so I need hello is the key, and stack at. So that actually is a method that says, okay, the key is on the top of the stack, pull the, go to the object that's under that and pull out whatever hello is. So when that happens, you find it actually leaves the hello world on the stack. So I found that working with these objects, the standard Forth idiom that it always absorbs the arguments isn't helpful because it was destroying the object all the time. And I'm trying to call multiple methods on the same object. So I was ending up with a lot of dupes all over the place. So I don't know if I've committed sort of huge crimes in going down this path, but to get around that, I have basically all the operators have one with the minus at the end of it, and that actually absorbs the actual object. So then I just get world out. All right, so that's me yapping for 13 minutes. Is there any questions about Python implementations? So yeah, so you've got all things like the table of all the symbols to what they actually map to in Forth. Add word, add sigil, import. And the actual execution loop of it is actually quite small because it's execute guards. Yeah, so obviously Python's a pretty cool language for doing this sort of manipulation and things in it. So yeah, it's I'd say it's 80% of the way to in fact it's probably 90% of the way. There's a few edge cases, but because of my application for it, I don't need backwards compatibility with these Forths. I just need something that's extremely bulletproof, and that's what I've tried to build with this cube Forth. So that would be my, yeah.
So you showed JSON objects, and
Yep.
you showed store. You use store to put the value into a JSON key.
Yep.
So can you show us some other interesting things you can do with the JSON objects themselves?
Yeah. So the so in this case, in memory, I've got a foo. So the foo memory location contains a JSON object, which is a dictionary on that sort of things. Now there's operators that I've got that you can do things like foo, and then you do that and at. Is it? Now this is where I haven't written this stuff down, and I'm not saying I'm super rusty on it, but I'm a little rusty. There's JSON load, there's JSON save, there's the standard ones. So if I pull that out of memory, so that puts it on the stack. I've then got the s at, and that would actually do world, but there should be the opposite of that. So if I put 55 and we'll go stack save, no, that's not going to work. I will have a look at object list. That's the handy thing with Python. These doc strings act as blocks of code, and these are the sanity checks that the interpreter runs on startup. So yeah, I'm playing around with getting things like in the Python structures. So I've overridden what a colon is capable of doing and moved the square brackets, which is the immediate code, to immediate. So immediate becomes that, because in my coding, I don't use that very often. Yet indexing into objects is something that you do. 99 length. So where do I use that? I'm just trying to think of the best place to show you that JSON stuff. But there's enough access things that a couple of things on the stack, and you can get access to the complex JSON objects. And I've been using it to do some testing.
Thanks, Scott. That's really interesting.
Yeah, so you can dig it. It's MIT license sitting on GitHub.
Mm-hmm.
So, and the cube Forth, and at the moment there's what we got. So there's my long-term support trunk, which is when I get something I'm happy with, I push it to that. Trunk 20 is what we're working on at the moment. I suspect in another couple of months I'll be pushing this trunk 2 back to here and calling it version 3 that we're working on. I'm mucking around with documentation and things like that for it at the moment. But yeah, no, I found it really interesting. I'm really happy with it. I conceptually, I know that this is a very contained piece of the bigger picture in terms of, because the exchange takes in from the public these programs and runs them against each other. And I need to make sure that, you know, it's not a gaping hole in security sense. Mm-hmm. And I'm happy that actually works with that. So yeah.
Yeah, so Dimitri had a question.
First of all, I think this is actually a really good use of Forth and Python. I was working on something a lot like this, but it was actually for generating hardware, like a kind of Forth implemented in Python, and you can generate Verilog from that. So I think it's good to combine the two together. But one question I have as a Python programmer is, can you make use of double underscore methods in this
sure.
implementation? You can.
Yeah, that when I called, what was it? So I was doing things like hello dot. If you do double underscore foo there, then you've just called a double underscore method. You know, get at her, that type of stuff. And then you can pass in a string to get at her on hello, but that won't work. Yeah, that should actually work. If we put in a hello, we'll try a double underscore as a hello world. So that's my JSON object. I can then call dot. Is it get? It's get item, isn't it? Get item hello. Didn't like that one. Get item.
Do you need to do a JSON load there?
I've done that the wrong way around. That's all. Yep. So that's called double underscore. That's the dictionary magic to do a dictionary lookup on that. And yeah, so that'll work. Obviously, in my sandboxed world, you're not allowed to do that because that's asking for trouble. But as for writing general purpose stuff, it's good. So, but I found with the testing code that I'm writing in the bigger system, I'm actually writing it in CubeForth because it's just easy to manipulate stuff. It's actually a lot more compact than Python. Yeah, so it's worth. I found it valuable.
Yeah, Scott, thank you very much. Are there any additional questions? I'm also the clock guard.
While the answer was being given there. So
Yeah.
I missed it, but I can always review that in the recording.
Yeah, okay, sure.
I'm sure I'm certainly happy to answer questions or yeah, or put a questions on the GitHub under the questions there. If you've got anything, I'm happy to. Yeah, cool.
Okay, yeah, thanks. Very interesting, and especially using Forth-like structures as a glue language for some other and inherit all the capabilities of the other languages. That's a very nice technique here to use it.
For sure. And I was just going to say, my complete HTTP library is 124 lines of code, and that gets me all my JSON HTTP wrapper around the Python wrapper. And so that's just really neat being able to do that. Yep. So,
great. Yeah.
Cool.
We will certainly follow up on that and see what this is about. So thank you.
Sure. No worries.
So our next speaker is Peter Jackaky from Australia, and it's getting late there again. Peter, you talk about rapid prototyping hardware and debugging with Forth, also something that every one of us should have in its tool set. And yeah, are you prepared to give your slides? Scott, you need to unshare your screen so that Peter can go ahead.
All right, you are steering, stop steering.
Hi everyone. Yes.
Hello.
I'm still setting up here, and but that's okay. I'll show you what I've got here, and I was just hooking up a few different boards. Some of you may have seen the forum lately where I've had a logic analyzer that uses a serial terminal, and I just wanted to set this up here just to show you how I may go about it. I have two different platforms that I can show you at the moment. I have the P2 processor, the Parallel X8 core processor, and I also have the RP2040 Pico. what I'll just do is I'll share this part of the screen. I'll see if I can get this set up right here. So just coming up off the other PC. Terminal. Oh, terminal's not bad. I'll just try to get a particular area here. Done this before, so I just have to find this again. Okay, we can share one part of the screen. That's the advanced part, is it? Here we go, portion of the screen. Okay, very good. Control. Okay. And what do we do now? Share and, all right, so what I'll just do, I'll just get this first. And hopefully,
yeah, we see it.
Yes, that's the one. And what I should do, I'll drag it across to this one over here. Let's see. All right. I should see that. I'll bring that down a bit more. I'll leave it as it is. Yes, that will do. Okay. All right. So we've got that. So, oh, that's not the screen, is it? Okay, I haven't seen it update yet. So what I'll do is I'll just bring that back across again. Change it over. Oh, I don't know what it's doing at the moment. So, okay, how are we going? Is that changing? I can't see it changing up here. I'm not quite sure what it's doing at the moment. Just stop the share for the moment and do that again. Excuse me for the moment. Share the screen. Advanced portion of the screen and share. Now, comes up in the same spot. Now, what have I got? Okay, all right, that's fair enough. I'll do that one. All right, so we've got a terminal screen up here. You can see that well enough. And we have another terminal screen I'll bring across. That just means I can swap this around quite easily. All right, so this one's the P2 terminal screen at the moment. I have all these different modules, as you can see up here, loaded up. I have the logic analyzer module loaded up in this one as well. So what I'm going to do is I'll just do a quick words, just so you can see what's up there. And then we're going to go in and run SLAT. And just making sure this is coming up here. Yes, there we go. I haven't updated this one. The Pico one is the one I've been updating. This should go wider, but it's not. So I'll jump back up into the console and I'll just set up the width at the moment like this and resume. Unfortunately, yes, but tiny minor problem. So at the moment, you see down the bottom, this logic analyzer is set up for a scale of 6 nanosecond samples. And we can move along those samples, etc. And what I've done is I've hooked up one of these little, I don't have a spare one here, but one of those little rotary encoders. I've hooked that up to 24, 25, 26. I'm not even sure what pins are what on there at the moment, but I can see some activity coming up on there. So what I'm going to do is change the channels, narrow this down a little bit and drop this down to channels 24 through to 31. We can see these parameters coming up down the bottom of the screen down here, and set that to the channels. And that way I'm just, these are the channels of interest at the moment. Just to, yes, so that should be fine. And I think if I tell it to run, I'm not sure if I've got this set up right, but I'll just tell it to run. It should, yes, it's indicating activity. Obviously, it's going way too fast. So let's stop that. Oh, I didn't mean to jump to the console, but I'll resume again. And what I'm going to do now is change the time base. Let's change that to 100 microseconds. So there we go. Tell it to run continuously. And it's still too fast. So let's drop that back to, I've done it again, 1 millisecond. And tell it to run continuously. See if we can get anything out of it. So what we're trying to do here is use Forth. We use Forth to debug hardware. Many times we have the logic analyzer and the oscilloscope hooked up as well. We don't always have the luxury of having that equipment here, and some of you mightn't have this equipment. So here you can have it. It's just loaded onto your Forth board and a serial terminal. Now, what we're going to do is just tell that to run continually and see if we can get this to talk to us. For some reason, I'm doing something very wrong here at the moment. So just resume, and I'll change the time base to 500 microseconds. Run continuously. The upper left-hand corners has two, the actual trigger up here. And yes, something's happening there now. Okay, so I'm pressing the button, This is supposed to have pull-ups on it, I think. But obviously, yes, I'm still going way too fast, so I should trigger on this one. And unfortunately, I haven't updated this one. It hasn't got the trigger set up properly on it. So what I'm going to do is just show you the Pico one and see if I can do something with this Pico as well. So what I'll do is I'll plug that across here to the Pico. I have a little Pico board up on here. That's actually just hiding underneath the display here. And so what I'm going to do is just talk to this board at the moment. And it's running me crisp. I have my Tachyon extensions on there. I still haven't gotten around to writing Tachyon for this one yet. But over here on my Visual Studio Code, I'll just tell that to load in Splat. All right. We can leave the terminal open. This is a good thing. You know, we can on Linux, we can have the terminal open and we can still load into it at the same time. So rather than backing that up, I have that hooked up to a control key. I'll just tell that to run there. So you can see that okay. I'll bring that up a bit larger and a bit larger again maybe, and even drop down the number of channels on there. Perhaps too large for the screen here at the moment, so I'll drop this back without adjusting that. What do you see there now? It's just mainly, well, rubbish really, but I'm going to tell this to do stimulate the outputs on here with different pulse width modulations, you know, different rates and different duty cycles, because the Pico, the RP2040 has many channels that we can configure. So I told it to run this little stim program, and I'll resume, Control R will do, resume, and tell it to trigger just on anything. And we can see the output there now. And up the very top, you notice we even have the labels up here for UART, etc. The different pin functions that the RP2040 is configured to. Any labels on the right-hand side that I may give it, I can just add labels manually or from a file, and we can see the waveform from there. We can make that wider as well, 120 wide, perhaps too wide for this screen at the moment. I'll leave it at that. Increase the terminal width, make it 120 wide again. There we go. All right, so we can scroll through there, many different things we can do, etc. Stop that and take it back home again, move the cursor along. We can even configure this terminal up for decoding asynchronous serial. I have different protocol encoders I can build into it, but if I say that's 9.21.600 board, it will now configure the time base for that. So if I capture anything, but see the very top trace up there is actually decoding. We see an FA there, it's decoded, and I'm not saying this is totally perfect, a 5, etc. So it's just decoding all that information up there. I'm going to make it better than that, of course, but it's just a useful little tool for me at the moment. And swapping back to the normal time base, I'll trigger this again, and we can see that we have the different pulse widths there. Why don't we get another one here? We have one called servo at the moment up on 20, on what is it, 21, this one down here. So I'm going to just, there's nothing much on there at the moment, so I'm just going to tell this one to do a 50% cycle. I'm trying to think what my, just a moment, I'll just double check what my syntax is for this. I have one where I can set up the frequency and everything on there. So I'll tell it that I want 50% cycle out 50 out of 100 down here. And also what frequency I want. Make it 100 kilohertz. All right, and which pin? Well, why don't we make another pin? We'll make it pin 22. So seeing we're down there now, pin 22, and that's PWM hertz. Correct. Now, when I resume, I can just do Control R, trigger that. We can see that we have a new waveform down there on this channel down here. And that is the, let's give it a label. This is our demo one, 22. So let's go back. And 22, it has a label called demo. All right. And then resume. And there we are. There's a label up there, demo. And so this is a 100 kilohertz, 50% duty cycle. We're going to drop that duty cycle back down again now. I'll have to drop out to do this, and 100. And what I'm going to do is maintain the same frequency and on that same pin. So PWM hertz and resume. And so we can see the duty cycle has changed. So this is very useful. You can use it to debug the signals coming in and out of the processor itself, or use it on another processor. The Pico modules are very cheap, and you can use that to debug your ESP32 signals and so on. Unfortunately, I didn't have that encoder set up very well. I don't know how I'm going for time. So I'm just trying to show you a couple of little things like this, where I can use the logic analyzer itself to debug the signals. So when I have a servo signal, for instance, I want to be able to maintain a certain duty cycle. Can't remember the actual refresh rates, etc. And I don't need the scope. The terminal is the scope here. This one isn't calibrated at the moment, so it says 16 nanoseconds, but it's on a slow capture. It's 144 nanosecond sample time. I think I can make it 10 times faster. I just haven't done that quite yet on this one for the Pico. But we can certainly see the serial traffic coming through up on the top on the UART and all the different signals there. So that makes it very handy. If we had video signals coming through as well, we'd see that too. In fact, the P2, on the P2, the trouble with the P2 is it has 64 I/O pins, and each of those pins are smart pins. And you can configure, it's like a peripheral in a pin. But the only trouble is, one tiny little problem is that I can't read that pin with the same pin when it's in a smart pin mode. So what I'm doing on the Pico, I can't show you on the P2 unless I echo them back into other inputs, unfortunately. But otherwise, it's very fast, as you could see. And because it has 8 cores, I can dedicate a core just to totally capturing everything, triggering, and so on, and still be totally interactive in another core without any slowdown at all. You can see that back in here. I've got this one back up again now, and we have, I think I mentioned in there that I have all these cores running in there. How fast was it again? I'll just run that again from start. Resume, okay. And increase the number of channels, 0 to 31, or from 32 to 63. So we have 64 channels we can be capturing. And I'm telling that to run at the moment, but yes. So it's taking a while. I have a large sample buffer, so it's taking a while to fill up that buffer, obviously. Let's bring that back to that little decoder that I hooked in before, see if I can capture it now. So I'll go back. This was on pin 24 and 31. I'll just drop this back down again. And let's slow this right down. Let's go 2 millisecond time base. So we see that down there, 2000. For some reason, I have an extra 0.2 microsecond there. And so that's the actual time, scale for per sample. I'll tell that to run continuously. And may not see it because it's such a large sample, so I might have to actually change that. So I'll just keep turning this encoder around and see what we get out of it. Not good. Okay, right, what I'm going to do is I'm going to do something different now. I'm going to tell it to trigger on, I think it's pin 20. Try this like this. Obviously, I have to add more controls for this really slow capture mode, but that's taking way too long. So,
Peter, how similar or different are the P2 and Pico implementations?
well, the Pico one was borrowed from the P2, which was borrowed from the P1. I've added a few extras to the Pico, a few nice little things. I still have to go back to the P2 version and put in all the triggers, etc., in there, like I did on the Pico. So the Pico is quite nicely set up, but the P2 has a lot of power because of the multiple cores. So and there's a I really only did this about a year ago, the one for the P2, because the P1 was done back in 2015. I first did that, and it proved to be very useful at the time. It's certainly very useful out in the field when I don't have all the equipment with me, and I can just hook it up like that very quickly. The other thing too is that you know, it would be nice to do analog, but I haven't quite figured out how to get ASCII characters to show me the wavy lines, you know, in a nice manner anyway. But I'd like to be able to do that. Pico has some A to D channels. I can use that, for instance, so that would be really nice. Unfortunately, I'm not really, I had some other technical difficulties here before, and I haven't quite set up the demo the way I wanted. But if we have time later, maybe I can just come back to it. I'll have it set up and just show you very, very nicely how it all works, and how we can write a little decoder, for instance, in minutes, really, just by seeing the signals and working that out. Any questions?
Peter, this was amazing. And my question is, are you going to share the code for the Pico?
Oh yeah, yes. Obviously, it's on my Dropbox and my pCloud folder, and I've posted the links before for it. I can post them again, but you know they're always there. I have the Dropbox, which is I work from that, and that is my bleeding edge software. When I think it's stable, I copy it up to the pCloud folder and up to SourceForge, etc. So I have
because I see this is very useful for Francois Laguel, who is an expert in designing single board computers and retro computers. Also very useful for Jan Langevaad, who is designing a simulator, MC6800, and many other friends. And also Jason will be very happy to put this to work for his developments. This is very, very useful.
Yes, and that certainly, yeah, it's right away. Anybody can use it, really. It's very easy to adapt. I adapt it back to the MeChris Tachyon type version, so we can adapt it to any version, and it's very straightforward. 3 sections. You have the ANSI, if you don't have it already, just the standard stuff to draw ANSI in colors and positioning. The other part that does the capture, and another part, and the display, and also the configuration. So
I'm sorry, Christian Hinze will be very pleased to use this, for example, with his questions about encoder. This is fantastic for him.
Yes.
Yeah.
So I'll set that up, and that'll be fine. So yes.
And probably Christian, I know he writes very well and makes documents. He can make the document for you, for example, documentation about this.
Yes, certainly. There's you know, as you know, like just very quickly, I do also have the help screen. You know, a few little help items in there as well. there's a lot of other little things I can save to files, to the SD card files and so on. I can do all sorts of things like that as well, but I want to improve the triggers as well at the same time. So yes, thank you.
Yeah, that's really amazing. I have a question. Do you need any additional hardware outside, or is it sometimes just sufficient to use the inputs?
Certainly, I think sometimes you will use it on itself, and other times you'll use that on another board. So yeah, because sometimes the difficulty of simply having your Forth code generate do everything it has to do and monitor at the same time.
Yeah. But you don't need any capture electronics that is attached to the Pico or whatever.
No, that's it. It's just simply just a little Pico module itself. You know, in this particular case, and you can adapt it to anything else. But a Pico is fairly fast, and as I said, I'm sure I can make it a lot faster. It's just a very simple loop I put in there to capture and display. So
okay,
useful straight away.
I see. Okay, yeah, and you already answered one question that was raised in the chat, whether you use VT100 or escape sequence, anti-escape sequences. Yes, you do.
Yes.
Atle has a question. Go on, Atle.
The mic.
Yeah. Hear me?
Yeah.
Oh no, it was just about these escape codes for the terminal. If you have a different terminal than a VT100 compatible, what will happen?
You'll find that most of the codes, the ANSI VT100 is about the same, really. And I can use the Terraterm. I can use, I'm using Minicom, Pico, the Pico 1, etc. There's quite a few different terminals I've tested this on before. I think you could probably even go right back down to what was the one that they had on Windows many years ago. I've even done anti-escape sequences on there for industrial control panels. So they all work. And,
excellent.
There's you know, like the attributes for blink, bold, underline are there, your different colors, reverse, etc. All available. We just need line drawing. It'd be nice to do line drawing.
Right. Are there any other questions?
Yes, Christian has a question.
Christian, go ahead.
We saw how to use this logic analyzer. I'm more curious on the design of the logic analyzer. What are the basic building blocks required to achieve this?
Yeah, of course, obviously in hardware, it's no extra hardware. All right, you simply have that. The logic analyzer is just taking logic level signals. But in terms of code, it's only a few K code. Well, in fact, I don't think it's even that much either. So it's a very small bit of code. It's up on my Dropbox. So I can just show you very quickly, just even up on here, for instance. I'll just share that screen very quickly for this particular one here. Okay, I'm just getting the right. I tell you what, I'll just do that. I'll just do that little window again because that's the easiest way to do it. So I'll just share that window. Okay, and I'll bring across a bit of the code across here, and so I'll get rid of that. Okay, so we can see this. So what I'm looking at, that's not it. Over here. Here we go. I'll go right down to here and trigger and capture. One line of trigger, one line of fast capture, a few lines of just general capture, etc. And even just two lines of code basically will do the labels. We'll set the label and display the labels, etc. Over here is the actual display code. Very simple. I have one for the logic analyzer color so that we don't have colors that we can't use. So it just picks out one of these colors. and also different things I display on the screen to draw a border, whether to draw a grid or not, the ruler, the grid. As you can see, it's very simple. ASCII decoder here to find out what baud rate I'm running at and to work out whether there's a character there or not, and part of the cursor that runs down the screen, etc. So you can see it's very straightforward. Printing a row, printing a channel, the information on the left-hand side, for instance, and the logic analyzer display part itself. Here it is. That's it.
Peter, this is an outstanding example why we love Forth. In any other languages, such a logic analyzer would be much more complicated to write and much more work for Peter, and he works alone. This is why he loves Forth.
Yes, and we're not. And the thing is that we don't lose our focus. We might do something like this, write a little tool. I write tools all the time, and I can get on with the job. I'm not spending the next 3 years perfecting this tool, and forgetting what my focus is. And it's when I design something, I get a product out. I just pick up any old board here, but design the boards, get them out, get them working, and solve the problem.
So if I understand right, you have two basic building blocks. One is acquire data, the other one is display data.
Yes, and
within each one of these, you have controls.
Yep, and I've set them up so I control different shortcut keys, and of course there's a configuration one, which is really just to allow you to enter things, etc., and change them. You can change them from the command line if you want to drop to that, but otherwise I build it in there, and that just works. It's very fast, and as I said, there's nothing much to it. If I load that in, it's only a few K. I can't remember exactly how many K of code that is. That depends. Chris tends to take up a bit more room. Here I've got a mention of it in here on my P2. 2,154 bytes. Terrible, isn't it? Yes. So I'm sure you can fit it onto a 6502 or anything easily.
Do you think this could be feasible on an ESP32?
Yes, although the capture part of it, whether you can dedicate the real time, I'm not quite sure how that works with the ESP32, because basically on a slow polling method you can do it, but if you really wanted to capture at full speed, I'm not quite sure what mechanisms we got, because you have the RTOS in there, haven't you, and everything you have to work with.
Well, even it's not so fast like the propeller or like the Pico. On the ESP32, it would resolve your questions about encoder, Christian.
Yes, plenty fast for that.
And some sensors, if you have, for example, a complex board like Atle did a complex board with a lot of sensors, inputs and outputs, and they are not so fast. And he could use this code to debug, of course.
Exactly. It's just you just have it sitting there or loaded in. It only just takes a second to load in, have it running. That's what's happening. I see there's an extra clock pulse or the edge, and you can see that straight away. So I'll put the extra triggers in here. On the Pico version, I have triggers, but I'll just improve it a bit more and try it out in the decoder. I'll have a little sample file that shows you how to use the logic analyzer on some common devices.
From what I read, the ESP32 has a basic I/O bus that runs at 80 megahertz. How does it compare to the Pico and the Prop2?
I don't think that's a problem with the I/O bus. If they can read at 80 megahertz speeds, that's great. That means but normally you have to read, and then you have to write, and then you have to loop. Whether you have DMA or anything like that. On the P2, I can read as you saw, I can read basically at half the clock rate, so it might be 180 megahertz. You know, that's it. I can read and write. I'm pretty sure that's how it works out to. So it I might be wrong, but on the ESP32, it'll come back down to the software, whether the software that, because you have to run that for everything else in there. So I haven't had enough experience with the ESP32 to be able to tell you exactly how that runs, but it'll be fast. You know, you'll be slowing it down because what do you want to do? Most signals that we get are below 1 megahertz.
So more or less, multiprocessor is better than single.
Yes.
Okay,
Yeah,
so it answered my questions. Oh, maybe one more. Is there any protocol decode?
What I'm looking at is like I'm looking at putting little modules in here. I did one just to look at working out baud rates, etc. I want to make that more flexible and a better display. But it may be that I might tie in with SIGROC. You know, they have that open source display on the PC, and they have protocol decoders in there. I'm thinking, oh, I could do it in Forth. That's fun, but also, you know, it's useful to have that interface there to talk to it. So I may experiment with that, and
So
we'll have
you
that
would
in there.
give SIGROC the raw data, and they would do the analysis.
Yeah, essentially that's right, because you know SIGROC sort of sends through the what SCPI, what are they called again? But the serial commands, etc. And to this, and it'll just respond back with the data in the correct format and display it up there. And but as I said, I can also write protocol decoders in Forth quite easily, you know, with that.
You answered my question. Thanks, Peter.
Right, very good. Thank you.
Okay, yeah, thank you very much again. And yeah, I think we shall proceed. Any other questions to Peter just can be done in the Forth Cafe afterwards or directly to him. And you're probably available in the next meeting and in between. So let's go to our next speaker. That's Jason. And Jason will talk about benchmarking ESP32 programs. That's probably something we also want to have in our tool set. And yeah, Jason, are you ready?
Yes.
Okay, then the stage is yours.
Thank you. Let's have a go then. Right, I believe this is the one. Okay, does that all come out well for you?
Yeah, nice.
Okay, so benchmarking on the ESP32 Forth, it all started off very innocently, really. I suppose the question you might start off with is, you know, why do it, right? Okay, I actually have to switch to my presentation itself, otherwise I can't. That's okay. Right, so why bother? It all started very innocently. I was just trying to understand, you know, when you are writing programs on ESP32 Forth, what is the throughput? Are we talking about, you know, 200,000 words per second? Is it 500,000 words per second? Is it 1 million words per second? And you know, I believe that there was not really a need for me to go very deeply, like actually understanding, you know, what is the interpreter actual throughput. You know, in that case, you would have to dig into the internals and see how it's written, and then see how often it's issuing another word. Because in fact, some of the words that we use may issue multiple dictionary words, perhaps. And I wasn't really necessarily interested in it. I just wanted to know, you know, the real words that I'm writing at Notepad or the terminal or whatever. You know, how many can I expect to be issued in a second? So that gives you a sense of the scale of the sorts of problems that you think you can tackle, right? You know, you don't want to start tackling a project only to find later on that, oh, it may not be up to the task, right? You want to have some sort of sense that you're in the ballpark already. You can more or less do it. And then the other one, obviously, is to understand language quirks, right? I mean, especially as a beginner, you quite often want to get in very quickly into something, right? You want to understand, should I use this language construct? Should I use that language construct? Which is better? And as we'll see, quite a few of these turned up. And the benchmark isn't meant to be very exhaustive. I know it's a very simple test, but actually it came off the back of some other tests that I saw people doing where they were doing empty loops, in fact. And to be honest, in my entire life, I'd never thought of doing empty loops before, but there you have it. Some benchmarks are even empty loops, and people can get useful information out of that. So I worked on the idea of millions of operations per second. At some point, I thought, since it's Forth and we deal with words, when you talk about writing speed and all that, people talk about words per minute, right? I thought it might be interesting to have millions of words per minute. Some of us really like to know. And along my research, as it happens, just searching for something else, not even searching for benchmarks, just looking at Forth microcontroller, you will see that in fact questions like is Forth fast, and we have a certain member of the group appears here, right? Howerd Oakfoard, and then how fast is the Forth language and so on. So it's clearly something that people think about at some point or other for various reasons. And some of it is maybe, you're writing a Forth interpreter and you want to know how fast it's going. So initially, I did not intend to check against the speed of MicroPython at all. In truth, I don't use MicroPython on microcontrollers. I already have a certain amount of grief over it at work, because we see a trend where people are putting where they could have used a 1 megahertz microcontroller before, they're putting 100 megahertz microcontroller in, just so that everybody can use MicroPython, right? And I don't know, maybe I'm a dinosaur, but it doesn't make sense to my type of engineering. But as it happens later on, I felt that having our benchmarks standing in an island without some sort of context, might not mean as much. So it's not a case of beating down MicroPython or anything like that. It's just a case of where are we? Okay, fine. It's like we get a speed of like 1.5 million words per second. What does that mean? Compared to other tools you might want to use. So I actually had to come back and do some benchmarking on MicroPython later on, and and initially the speeds were quite different, and I was a bit surprised by that. But then I realized that in fact MicroPython starts up by default at 160 megahertz, and you actually have to speed it up to 240 megahertz if you want apples for apples. So there we have it. You could say that MicroPython does an equivalent of around actually 1 million operation or words per second, or almost 61 million words per minute. This is the code that I used on both. Like I said, it's not supposed to be highly optimized. The idea was that if it were just me or Christian or anyone else approaching it, this is the first thing we would probably type in, right? And how do they compare to each other? And all it does is it takes the initial start time in microseconds since boot up, and then it runs essentially I square pi and essentially discard the result a certain number of times, in this case 100,000 or 200,000 times. This figure of how many times I iterate is just a matter of making sure that we don't end up with a milliseconds that's too low, right? Because then you lose precision. Although in reality, we're after ballparks anyway, so it doesn't matter. And then after that, we take the time when we complete, and we take the difference and so on, and then we do a little bit of maths to figure out how many words per second that was, right? And then, as it happens, later on, so you'll see that, in fact, I initially I was also trying to look at the speed of the new floating point stack that Brad Nelson had implemented, right? So that's what I was doing. But then I thought I should go back to it and then do the integer implementation. And initially, I was using the code on the left, right, where I had a separate, where I was doing fixed point math, and I was doing the scaling separately later on. And as we discover in the results that well, Forth has a built-in multiplication with scaling word. That's the star divide word, right? That in fact you should use, and we'll see how that affects everything. Okay, so what I did was, the general procedure was confirm the operating frequency of the board and the various interpreters. I checked that the value being produced during all the iterations was as we expect. That was done using different scripts, right, to output text, which is not shown here, just to be sure that nothing strange was going on. Especially when when you get these results that are wildly different from what you expected, then you have to go and find out what's going on. We run the benchmark several times to make sure that you don't get values that keep going up and down or oscillating or whatever. And just now confirm came about. Basically, I just turned the LED on and off in an additional test, just because at some point I started to get results that were so wildly different that I needed to make sure that we weren't having a problem with milliseconds timing, tracking, and so on. So let's get right into it. Now I don't have the whole battery of tests that were done on MicroPython. I only did the floating point one. So you see MicroPython essentially comes out at a scaling of 1 here, right? This is our control. And then what we find is that on the ESP32, we find that I found initially that it was about 1.6 times faster. And all right, fine, that makes sense, because MicroPython has object creation, garbage collection, all kinds of things. You'd sort of expect that, right? And then I also tested the ESP32C3, the RISC-V version. That one runs at 160 megahertz, I think. And then if you see that, then I tried the integer version, and I was a little bit surprised to find that in this case, ESP32 came out at only 1.3 times faster. But then I realized then, in fact, that what was going on was that, in a sense, I was using a separate divide function. Now, when I switched instead to using the built-in Forth star divide word, of course, then performance came back up again. Now, why is that? That tells us that, in fact, that interpreter overhead is big enough that if you run essentially if you run the built-in compound word, that in fact your main concern is interpreter overhead, right? And in fact, we can also get another conclusion out of this, is that even though the C3 does not have a floating point unit, interpreter overhead means that even if you're using emulated software floating point, you're not losing out hugely in comparison with the ESP32, which does have a hardware floating point unit. So that's good. And then running the test, at some point, I realized that, in fact, I wasn't using the very latest version of ESP32Forth. And when I switched to the latest version of ESP32Forth and tried everything again, this is what I got. I was quite shocked, actually, because now we're seeing that when you're using the latest version, the .16 version of ESP32Forth, the speed went up hugely. I'm not sure what Brad Nelson did, but it must have been extremely good. You know, we're not talking about
I missed which version you were using before. I'm trying to guess what the difference is. What was the version you were on before?
Previous version was 7.0.6. Yeah.
Scratching my head.
So it's effectively like double the performance now. So you get it is now 2.96 times faster than MicroPython. So this really threw me for yeah. It shocked me so much. I thought I was timing things wrong. I thought I was doing something wrong, and then I actually spent. So you know, if you look at this, you know, this first few slides, this took me, you know, I don't know, almost nothing, right? And then I spent days on this, trying to find out whether I'd done something wrong. You know? But yeah.
Actually, can I see the benchmark? Actually, a second. I did happen to optimize variables in the midst of this. So if you were, let's see, were you using a variable? I'm now forgetting.
No, I wasn't.
No, you weren't.
I was
Okay,
just
now.
doing the.
Oh wow. Okay. Now you got me wondering the mystery of why the performance difference. That's awesome.
The only thing to say about this is that if you look at the you know, but it's not even part of the benchmark. It's just my conversion later on to find out the millions of words per second. I was a bit of a dope at the beginning, and I didn't realize there was a built-in reciprocal floating point function, which I started to use later on. Yeah. So yes, as far as I can tell, these results are real. So everyone can rejoice. And then as if that wasn't enough, then Peter said, you should use the for loop. So I went back and tried that again, and and get ready to be even more flabbergasted. So now with everything in a for loop, in floating point, you find that ESP32Forth, the latest version, is now 13 times faster than MicroPython, and the integer version of the benchmark is 6.5 times faster than MicroPython. But then, you know, I didn't do an integer version on MicroPython, so I wouldn't really know. But as I said, you know, my initial intention wasn't really to compare against MicroPython. Yeah, Ted has his hand up.
Yes, thanks, Jason. I have just a few observations. First of all, this is a really excellent presentation. I don't mean to disparage anything you said, but you sort of like say you're measuring millions of words per second or minute, but you're really not, because there's lots of words in your loop.
Yes, actually.
Yeah, but really I see the value here where of iterating your own code. You've improved your own code and gone from 3 times a basic benchmark to 13 times a basic benchmark. This is really excellent. It's an excellent way to look at your time-sensitive code, etc., and really optimize it.
Well, I mean, it's worth saying that I didn't know what I was doing, and I still don't know what I'm doing, and I was very surprised to I was very surprised as to where it took me. I didn't know I was going to get here at all. And you know, I was looking at the starting forth book and so on, and it didn't mention the for, after, then, next at all.
Jason, we will share your code if you share with us
Yes.
both parts, Python and Forth, and we can put this on the Forth 2020 GitHub, and we keep improving for next For next presentation, we show more about this. Probably the code will change or so.
Yes, yes. I mean, otherwise you could be writing code, especially you know, there's no point to optimize the whole program, as everybody knows, you know. But there's always gonna be some sort of small critical path where it's worthwhile to do a bit of optimization. Okay, so
I'm less. By the way, I'm less surprised with the for loop versus the do loop. There is quite a bit of plumbing that has to happen around a do loop, and so yeah, Dr. Ting is no doubt smiling if he's either here or from afar, as he's a big proponent of the for loop. But
yes. In fact, the only place I could find the documentation for the for loop was in Dr. Ting's documents. Okay, so this is the code that I used, and once again, I was a bit of a dope, and I was copying different versions. But anyway, you see the intention with the different iteration numbers was simply just so that I didn't have excessively small milliseconds coming out. Okay, and then this is not something I did initially, but you know, when Peter says, "Can you make a presentation?" all of a sudden you crap your pants and say, "Oh gosh, you know, I've got to get a bit serious here." And yeah, the reason for the confused basketball player in the corner is because well, you know, we see the ESP32 firmware sizes here. Where's the MicroPython size? Well, actually, it's there. It's just that it's so small you can't see it. It's actually I think they're like 1.5 megs. For the it's 1.5. I don't know. Let's see. What is it? Yeah, it doesn't appear. It doesn't appear. It's in there. No. Sorry. I've typed this up wrongly, I think. So MicroPython is actually 1.5 megs, and ESP32 comes out at about 877 kilobytes in size. But remember, that's also because it includes a lot of fourth source that gets compiled at boot up. So, you know, maybe slightly misleading there.
The difference is in ESP32 you have a lot of tools. You have an editor, you have the web interface, all these things. Yeah, that's right. Yeah, I think I've got some of this wrong somewhere. This can be a next experiment for you to go after.
Yeah,
the part of the tools, how much memory each is using.
Yeah, I think I've screwed this up actually somehow. This doesn't sound right at all. Yeah, so conclusions. The version of the presentation I sent to Peter actually didn't have any conclusions at all, because I thought it sort of spoke for itself, but then we can come up with some conclusions actually. One of the suggestions that Peter had was use constants, and in fact, the pi built-in word is very slightly faster than using literal constants. I have no idea why. And then we now know that for next is much faster. Yes, we understand that do loop does a lot of stack manipulation, and interpreter overhead. You know, interpreter overhead features very heavily in the benchmarks that we can see. So wherever you can, definitely use compound words. And that's about it. I think in future, what I would like to look at, you know, I would say that I considered, you know, for next as an additional word, and then I considered do loop as one word, right? Which in reality it's several stack manipulations. So it's not quite right. But to me, when I look at it, I think, okay, you know, about 3, you can sort of expect about 3 million words per second to happen on the latest version of ESP32.4. And then you should have some sort of an idea. If you were trying to think, okay, if I wanted to measure a signal of a certain speed, entirely within Forth without dropping into Arduino and writing special words in C and so on, would I get away with it? Then at least you would have some sort of an idea of what it can do. And also, everybody update to the latest version.
Yeah. So yeah, thank you very much. There's a question from Matteo in the chat. And he says, why do you use different amount of iterations in these various loops?
Oh, yes. Well, it's simply because I started off with about 100,000 iterations. And then I also tried 200,000 iterations to see whether there was a big difference. The main intention was to stay within about, between like 400 to 600 milliseconds execution time. And then later on, when I got to the for loop, of course, for loops, threw everything out the window, right? And you had to use a longer iteration. That was the only reason, really.
I see.
That's fine.
Yeah, thank you very much. Are there other questions? Yeah, Jan is raising his hand.
Yes, I have a question about changing the speed from 160 megahertz to 240 megahertz. How did you do that?
I think there is a system module that you need to include. Yes, sir. Okay, no, I believe it's in SYS. It appears in the post I originally did in the Forth 2020 group. Do you mean how do we do that in Forth, or how do we do that in MicroPython?
In Forth, please.
All right, I see. I didn't try that. There are words for getting the frequency that already exist, but I didn't try to change the speed in Forth. I only did it for MicroPython because it was coming in slow at boot up. Maybe
Okay,
Brad can answer that.
Yes, I was going to ask him.
Sorry, was looking at the chat. Sorry, what was the question? I didn't quite get that.
How do you change the operating frequency in Forth?
I don't know that I have anything exposed that does. That's a good thing we should add, actually. Do you know why MicroPython just doesn't go with the fastest clock speed? I guess it's a power thing, right? Flexibility for low power.
Yeah, I guess so. I was surprised.
Yeah, it's a little counterintuitive that they would default it to the lower clock speed.
Yeah, and if I didn't happen to check, then and the reason why I checked was simply because after I updated to the latest version of ESP32.4, I got those wild numbers. I thought, whoa, what's going on here?
Right.
So if anyone one day finds out how to do it in Forth, I would ask you to announce it on the Facebook group, because I need the speed a lot.
At least the default one you can set in the Arduino IDE when you pass it. So like that will set the initial value. I don't know. I need to look into what's involved in dynamic updating. But if you just want to set it globally, you can set it in the Arduino IDE in fact. U32.4.
Okay.
Are there any questions? Other questions? Right. So then we proceed to the next speaker.
Yes, Ulrich, it's your time with the wonderful, and I love so much this force. This is the volksForth from the German Fick. And Ulrich Hofmann will show us a little bit about.
A little bit about it. Yeah, volksForth, 35 years later. And so let's see what we want to do. We would want to look at what volksForth actually is. I give some short introduction. We look a little bit at its history and its features and the different platforms it runs on. And I recently had a look as being one of the authors originally, again, a look at volksForth and find that it has a very interesting collection of very special features that you don't find in any other Forth system. And I picked 4 of them, and we will discuss them, like dynamic binding of local variables, the heap data structure, headerless words, and interactive conditionals. And there are many others, it has a block buffer system, like many other Forth systems, but it could change the amount of buffers at runtime without crashing. And so if you're tight in your application code, you just say, well, I can live with 2 buffers. So, and you get another 2K with respect to the normal 4K, 4 buffers that were there. And then volksForth has been revived, and we will look a little bit in the future and get some conclusions. So, yeah, the volksForth was actually developed, I think, initiated by Klaus Schleisig, who's also in today's meeting. Hello, Klaus, welcome. And there was a group of people that were just surfing on the upcoming home computer wave, like C64 home computer and Atari ST computers, and I myself was involved with CPMs, Z80 systems, and so in 1984 the Forstgesellschaft was founded, and in 85 we started developing a system for the members of Forstgesellschaft. And so there were some guys that had 6502 computers, others like myself, 8080, Z80, others had Atari ST with 68,000. And Klaus was involved with the DOS version doing 8086 development. So from 85 to 89, we developed this, and we look at the feature set that volksForth actually achieved in a moment. And after 89, well, the mission was more or less completed. There was a common system on all the platforms that we will also look at that worked fine, and that was more or less complete. And so people moved on to different other things. And but still, volksForth is the foundation of other systems that are still in use today. It evolved into BigForth, a 32-bit system on the Atari ST and later on the PC, and Delta T-Forth, a commercial system that I was involved and Klaus was involved in. And eventually, BigForth evolved into GForth. If you are interested in the history of systems, Forth systems, Anton Ertel collected a huge family tree of Forth systems. And if you want your Forth system to be included there somewhere, because you said I'm inspired by FigForth and also by F83 or whatever, then just give Anton a note. He will happily include you in this family tree. So, but the actual volksForth development stopped more or less in 89. And then in 2005, Carsten Strothmann said, well, he's very active in the retro computing scene. He said, well, we have a great development system that runs on these old retro computers, on the home computers at that time. And so there was a revival movement. He collected all the diskettes and put them on GitHub. And so you can get hold of the old data and old source code of that time. And then Philip Zembrot jumped in, and Carsten and Philip started to continue development on volksForth. So they actually did some revisions, clarified things, scanned all the handbooks, and started to make it UNSFORTH compliant. Yeah. So what is volksForth? It's a self-contained interactive programming environment that once you boot it, you can do complete development inside volksForth. So that's really nice. So no need to use any external tools. That's the idea. At that time, computers were 8-bit computers, and the typical thing was that the Forth systems were 16-bit, and so that's also what volksForth is. It uses indirect threaded code as its execution technique, which I still think is very pleasant to use and very easy to understand. It allows you a lot of good manipulation of the code, even when it is already compiled. It runs in 64 kilobyte because if you have addresses that are just 16-bit, that's it. So the system takes some place, and your data takes some place, and then there is not much space left for the application program, looking at today's amounts of memory, even in microcontrollers. So, but later systems did segmentation, separated headers from the code, put the stacks in different areas, like what you did to overcome this. So it adheres to the Forth 83 standard at that time. That was in 85. That was the hot topic. And thus it's also called volksForth 83 in official terms, but I just refer it to volksForth because I don't see it tied to the Forth 83 standard. It's just that it happened at that time. We had a very huge, exhaustive manual, handbook, actually, that was printed at that time. PDF was not common, and so we handed out with the distribution of the diskettes, and people also got the chance to learn about this. It was mostly written in German, and that's probably something that we want to change. We have the scans, they will be OCR'd, and then we will go ahead and translate them in English and with volunteers to other languages. volksForth had an intrinsic assembler, so at any time, if you say performance is not right, you could go ahead and rewrite a high-level definition into code, and thus do this on the hotspots, which you would identify also by benchmarking. There are also profilers, but they are not in the core distribution, that allow you to identify the hotspots, and you could easily speed up words by this. The system had an embedded full-screen editor. Source code at that time was based on source blocks or source screens, 16 by 64 characters normally. Yeah, but it was very nice. It has search and replace capabilities, very easy shadow screen support, whatever for automatic documentation or for good documentation and so on. You had a decompiler for interactive and also for an automatic one. The interactive decompiler is especially interesting if you do compiling words, and the automatic decompiler doesn't know about the new compiled structure in the first place, then an interactive decompilation is very, very helpful. We had a multitasker, we had a single step tracer, so all the bells and whistles that you think, but volksForth never, well, it ran on its own on certain homebrew systems. That's where it started, but the typical volksForth 83 platforms had an underlying operating system, be it TOS on the Atari ST, or well, the ROM in the C64, or CPM or MS-DOS, yeah. The system itself came with complete source code and was written mainly in Forth itself. There was a meta compiler that allowed to regenerate the system and port it to different platforms and evolve it appropriately. And that was the way it does. We shared the source code of the core and made it actually very similar on the different platforms. So there was C64, as I said, CPM, Atari ST, DOS PCs, and all of the source, the volksForth core was more or less identical on all platforms. So you could port programs very easily from here to there on the supported platforms. And each platform itself had system-specific extensions, so to make full use of the system. And let's have a look at the different platforms. So there's the C64 version that came on 4 diskettes. At that time, the diskettes had 140K space, and if you wanted to load a program, you had to swap 2 of the disks constantly to actually load the appropriate source code and then have the right source code available. Because of the strange resolution of the C64, which was supposed to be used with television sets, the UltraForth, which it was also called UltraForth on the C64, used a screen editor with very strange screens of 24 lines that had 41 characters and 1 line that had 40 characters. So the lower right corner was dropped out, but if you calculate this, that gets you 1 kilobyte of characters. Very nice. And yeah, so it was used by a lot of people that had C64s at that time. And today, if you want to run it, you can run it in an emulator. For example, the Vice emulator that is used in the retro gaming scene for running the old C64 games, but you can use it to also run volksForth on it and get the old feeling of how things were at that time. The system I was involved with was volksForth on CPM. It was ported to CPM and CPM Plus systems, which was in itself a wide variety of hardware, where the hardware abstraction was mostly delivered by the CPM system. And there were also some home computers like the Amstrad Schneider CPC lines, 464, or similar computers with cassette interfaces. And you could use it there, and they had graphics capabilities. So the Amstrad CPC version adds turtle graphics and other system-specific extensions. Also, this system has interactive conditionals, which we will have a look at in just a moment. And if you want to use it today, at that time, a typical CPM system had a Z80 processor with 4 megahertz execution frequency, and things were, well, slow, comparable to C64. I used the emulator, and C64 was a little bit slower even. But you had to be patient at that time. But if you today use a modern CPU and use, for example, the Yase emulator that emulates CPM, you get something like a 150 megahertz or 200 megahertz Z80 CPU out of it. It's blazingly fast to use it there. Or you can even run the 8080 version online. There are people that provide CPM inside the browser, and then you can go ahead and have a look at it. Yeah, right. It has also been ported to the Atari ST, and then there was support for the GEM environment, the window environment there, and the DOS-like operating system that was the basis of the Atari software. Today you can run it again in an emulator like Atari, for example, which boots TOS and the GEM, and then you can just run volksForth on top of it. Or you go with the DOS version, which came with the DOS interface, and its outstanding feature is the status line. That is something that if you started, you immediately recognize, where at the bottom you would see the items on the stack, how much dictionary spaces are available, and you see it's 25K available on the DOS version if you boot up the vanilla system. And the open file and the search order and things like this. If you want to run it today, use DOSBox to do it, and that works quite well. And also, it's blazingly fast being there, not comparable to an XT at that time when we did it. Yeah, so that's the outstanding features that I see with volksForth was it was very easy to understand. So you had the full source code and the capability to just jump to certain certain parts of the source code, have a look at it, and understand it. It had a very complete feature set, what you needed for development, and it was somehow self-contained. So you didn't really. I had the feeling you need something else to do it. With a full screen editor for the source blocks and the nice capability, it had lines and character stacks to rearrange the source code, which were very handy. That worked quite well to do it. And with a meta compiler, you could do recompilation, porting the application to a specific to other platforms, or do specific tweaks for applications that you wanted to do. There was also a methodology how to port from one thing to the other. In the source code, you find for many code words, you also find high-level definitions. And the way to port from one system to the other was to substitute the code definitions by their high-level definitions. The system slowed down by this a lot, but more of it was written in high level. And then only a few primitives in code remained. And then you needed to write these in the assembly code of the new platform and do cross-compilation. And in the end, you get an image. Once it booted up, it was very slow because it contained all the high-level code. But then on the new platform, again, self-contained, you could just go ahead and substitute high-level definitions by the new assembler, step by step, always knowing when you make an error, what word caused the problem. So that was very, very nice. And it was a pleasure to port it to a different system like CPM in my case. And then volksForth has a very interesting set of special features that I have not found elsewhere. Probably, if you look at for it, you will get some of these. And of course, you will let me know. There's this forth system that has the same feature. Of course, we don't claim any exclusivity, but I would like to show you some of them. So one nice thing is the dynamic binding of variables, so they become local variables. In volksForth, there's a word push, which you use in the way push variable, and then it saves the current value or the return stack, but it doesn't matter. It saves the current value and allows you to change a variable, and it will be restored whenever the definition where push is used is exited. So as an example, you could define a word that regardless of base will always output a number in hexadecimal, but will not change base at all. So it stays as it is, and you use it this way. Base push is the old value, whatever that is on the return stack. So it will be only locally changed in the rest of the definition. Hex goes to hexadecimal, dot outputs the number in hexadecimal. And the semicolon will make sure that the old value is restored in base. So if you are in decimal and you say 100.hex, it temporarily switches to hex, outputs the number in hex, and restores the old value, which used to be 10 because of decimal, and the dot will actually print it in decimal. So you get the output 6400. The push feature is 3 or 4 lines in implementation. I think that's mainly also a speciality in volksForth. All these features that I present are very easy to implement. You are surprised if you look in the source code how few lines there are to implement these nice features. So that's, and you can use it for your own variable. Base is just a variable. It's a user variable actually because of the multitasker, but any ordinary variable will do as well. So if you want to change it for some temporary time, you can use base. The push on it, then that's quite easy. Right. Today, if we want to use dynamic memory, there is allocate and free ANSI standard. Yeah? But at that time, Forth 83 didn't have these kinds of things, and volksForth provided something that is similar. You could, it had a heap structure. It has stack and return stack, and it also had a heap structure where you could allocate certain amounts of data. And the word used for this was HALOT. You just gave it a number of bytes that you wanted to have, and it would reserve it. Okay, again, a typo, this is heap, of course. If you issued heap, then it would give you the address of the last allocated chunk of memory. The difference between allocate and free and HALOT is that you could not release certain fragments of memory, but you have to release all the reserved memory at once. And this is what the word clear is for. So let's see how it works. So you do just output where the heap actually starts, where is allocated memory. That's at this address, and then you can allocate 300 bytes, and then you ask again what is the start address of the newly allocated memory. That's 300 bytes less than it used to be before, and then you can just deal with that memory. You know it's 300 bytes long. You can just initialize it whatever you wish, and you can type some stuff of it. And once you're done and you say, okay, temporary memory no longer needed, you do clear, and then it resets this to its original version. The heap is actually located below the data stack. And if you HALOT something, then the stack is moved under the hood without any program noticing it. So it's below the bottom of the data stack. So, which is only important if you happen to capture some addresses of stack items, but that's not what you normally do. Yeah, so that's nice. So there's a way to have temporary memory that could be released at once, and this is actually used by for headerless words. Another feature that I haven't seen in any other Forth in this way. Many use, or some systems use the vertical bar to mark headerless words in target compilation mode, but not in an interactive system. Well, that's something that is unique, I think. So you store the header not in the dictionary, but then in the heap. We're doing an appropriate indirection to actually know where it is. And if you now clear, then it unlinks all the headerless word names so that their names are no longer visible, but the body remains. So you can define words that lose their name. And this is, of course, for memory preservation, to save memory, but also to just make intermediate helper words no longer be available for the application program. So as an example, we could do a headerless definition hello, just outputs hi. We can use hello in another word, greet, that calls it twice. And then if we do words, we see greet and we see bar hello, which means attention, this is a headerless word, and some other words. And we can invoke hi now, or we can invoke hello now, displays hi. We can invoke greet, displays hi twice. And if we clear, then we get rid of the temporary name. So hello can no longer be invoked, and but we still can invoke greet. It displays hi as before. And so hello is some internal word that is not used on the outside, and greet is the interface to the application program in that sense. Right, so that's headerless words. One feature that the CPM version of volksForth had, which was also astonishingly easy to implement, is interpret mode control structures. You can, of course, use them inside colon definitions, but you can also use them outside colon definition. This is done by temporarily compile an anonymous definition. And once you end the control structure, the outermost one, this gets executed. But to allow extending the dictionary inside the code that you execute, it's moved out of the way and executed somewhere else. It could be done on the heap, but it's actually moved to the return stack and executed there. Let's have a look at how it can be used. So in interactive mode, you can just do 10 0 do i.loop, and then it will just do it. This is useful for data structure initialization. So you can just create an ASCII table of uppercase ASCII values, and you just loop through the characters, and for each character you convert it to the uppercase letter and comma it in the dictionary. Yeah, and although do and loop will compile stuff, it will be moved out of the way, so you can actually extend the ASCII table by this. And you can then later on just index in it and type the printable characters in it. So skip over to space and then type the remaining 96 ASCII characters in the first code page, which gives you twice the capital letter because the initialization did it that way. Yeah, so just to give you an impression, of course, you could do a temporary definition that does the initialization that you would just invoke here, but this would be a definition that remained in the dictionary, and although it's only used in the initialization of the data structure. And remember, we have a very, very small system, so being tight in memory, then every definition that is not used is waste, then that is to be avoided. Right, so that's mainly it. So let's have a look at the future. I talked already about the revival of volksForth. It's used in the retro computing community because they want to do new programs on classical computers, and they are of course looking for development environments that can be used of advantage there, and volksForth is an environment like that. The data that Carsten collected is also available on SourceForge. You can download the binaries, or on GitHub for further development. You can find all the versions, and it has been ported to Apple I and also to Nintendo systems, depending on the CPU. So that's quite handy, or some handheld computers. So there are some more ports available than the classical ones. And also it runs the haste test that we saw earlier today as well. Some systems are already unforce compatible to move this. And I already talked about the idea of translating the handbooks We only have scans and they are not OCR'd right now. So this needs to be done. And once we have them machine readable, then translation should be easy thanks to the help of DeepL and some native speakers that will just go over it. So that's something that is planned for the near future. And so my conclusion is, at that time in '85, we developed a quite versatile tool during this home computer time. And that was really a pleasure to use at that time. And after re-investigating this, it's still a pleasure to use for me. Because it's so easy to understand and so compact, and it has what you need, and it's not overloaded at all. So that's quite nice. It's a foundation of BigForce and then eventually GForce. GForce developed further on, having many things, and is not as comprehensible as volksForth was, but has lots of more features, and you decide whether you need them or not. There was this revival in 2005, and my judgment is volksForth has many good ideas, and it's yet still easy to understand. So it's very pleasant to use. And we have this elaborated technique of porting it to other platforms as a native system. And I find it too bad to let it fade into oblivion and just let it forget. And it's worth to be ported to new platforms, and that's probably what I'm thinking to do as well, because it's as a tool, it's very important to also get a deep understanding of what it is. If you're an engineer and you have to be held, or you are held reliable for the things that you do, then you want to know what's going on, and a good understanding of the system will allow you to actually give the promise that the application that you do will actually do what it is, and there are no surprises in some underlying software. So for certain areas, for other areas, you just want to make it work, and you cross fingers that it works and get the experience. Yeah, but anyway, so are there any questions? Thank you very much for listening.
I have a question. I think the creating of the table with a headerless definition will positions in the table itself.
So Albert, you're very hard to understand, because we get maybe 10% of the words that you say.
Okay. Is it better now?
It's dim, but it's not fading away. Yeah.
There was an example of creating a table, and a temporary definition in a separate place. That is the technique I also use. That works, but a temporary definition wouldn't work, because the temporary definition would be present in the table itself, I think. Is that correct?
No, actually, if you do if you start the control structure, it will start a temporary definition, but this will be moved out of the way before execution.
Yeah, that I understand, and I use this technique. Yeah. But if you have a temporary definition, but a vertical bar.
No, you have to make that definition before you create the table.
Yeah, okay, that's yeah. Okay.
Of course, yeah. Otherwise, it would be where the table is supposed to be.
Yeah, that's a mistake. They is present in the Ford Scientific Library, because they do that. Yeah,
I see. So I saw there's some messages in the chat. I will go through them in just a moment, but I see that Ted is raising his hand.
Thank you for the presentation. It was great. So I used to use basically FigForth in the 80s through that era where you started that. How would I have gotten volksForth? There was no internet to find out a lot of things. Thank you.
There were actually some hints, some I would say ads in fourth dimensions. Many of the German force enthusiasts at that time were also member of the force interest group, and there were there were some hints. It was not obvious, of course. And then there was a mail order service. So in principle, you could have ordered it for some money at the German force office, and they would have sent it to you. Yeah, but for sure, no internet, distributing of force system on diskettes. That's on. Someone asks maybe Usenet.
I can also tell my experience with volksForth to Ted. Ted, I was subscriber of the fantastic Vierte Dimension, the fourth dimension mirror of the German FIG. And this was in the 80s, in the 85, 86, 87, those years. And I bought one volksForth diskette because they charged only the diskette. The software was free. It was 5 German D-Mark. And they sent this to my friend in Munich, and he sent me the diskette to Argentina. And it was a real pleasure, like Ulrich said. It was a compact force. It was a force with all the sources available. So you could learn. This was my purpose, to learn more about force. And amazing. I did a lot of programs with this volksForth. So using starting forth, of course, and other books. I think, Ulrich, did you mention the FigForth? Because volksForth was probably very inspired on FigForth.
Yes, yeah, in some sense, yes, it was, because Klaus,
6502.
Klaus can probably talk about that as well. But he was at that time, he was in San Francisco or in the Bay Area, and so he had contact to the FigForth developers. And then he came back to Europe with the idea, but it's very different from FigForth in many aspects. So doing things in another way. Yeah. But.
Yeah, I can give a little rap about how this all came about. Do you hear me?
Mm-hmm, yeah.
Oh,
Yes,
okay.
yes.
So the first thing I did was probably in 79. I put, or in 1980, I put FigForth on the AIM65, which was a very nice 6502 system. And I used this for a sound piece in the Dome for Tropical Plants in St. Paul, Minnesota. And later on, I moved to San Francisco. I got myself hands on an Apple I, and then I ported the Force with some already changes to the Apple, putting together my own metacompiler. And from there on, if you have your own metacompiler, then the evolution of this Force system is almost certain. And so I played around with many different principles and possibilities. And in the end, when I came back to Germany, then I don't know how we negotiated what volksForth should be, but we came to some conclusion somehow. Mm-hmm. And then it was ported to different machines and different CPUs.
Yeah. So we had meetings very long in the evening till early morning, discussing how to do things, how to name words with the group. And then eventually, the 6502 version was there as the blueprint. And this was ported to C64 and the Atari ST. And then I took the Atari version to port it to a CPM then.
Yes, then of course I think it was 87 or 86, I bought the Atari ST, the 520, and then I experimented the first programs it was the Big Forth from Bernd Peisand. I experimented this Forth. It was also very interesting because this had a GUI interface, so I could learn a lot with this. Also, all the German FIG guys were fantastic professors for my development. I thank you, all of them.
Okay, any more? Of course, I could do a demonstration at some later time.
Question?
Yeah, Christian.
Okay, I saw in volksForth a heap. I guess most Forth at the time didn't have one because the CPUs and the memory was expensive.
Yep.
But did volksForth prove that it was useful to have a heap, and would it be nice?
Yeah, yes, actually it was quite
today in bigger MCUs.
Yeah, it was actually quite useful, mainly also to conserve memory. For example, you could load the assembler inside the heap to not have it in the core system. So there was this intrinsic assembler. You at any point in time you could just do code and define words in assembly code, but then you have to load the assembler, and it needs to be present in the dictionary. But with a heap, you could load it into the heap, make your code definitions, and then release the heap memory, and the assembler would just be erased. So you could have code definitions without having the overhead of the assembler and the target system, which I think is still a issue with microcontrollers. So if you have an interactive system on a microcontroller and you're tight in space and you need to load the assembler, I know there's some techniques like comma code, where you made hex codes out of the assembly definitions, and then you load just these comma codes afterwards to preserve space. Depends on the system. I mean, if you have megabytes of flash memory, then that's not an issue. But yeah.
From what you just said, it feels like it was working like an overlay system.
Yeah, you could use it as an overlay system, but you could also use it for temporary storage in your application programs. So it's more or less like allocate and free that we have in today's
Are you
Forth.
aware of any other Forth that use a heap?
I can answer that. The assembler of my C-Forth uses a heap. In a sense that the assembler is loaded in halfway to the stack, so that's not used and thrown away afterwards. And I use this technique also for temporary definitions. It's a technique I have come across lots of times, actually.
Okay. Thank you.
Okay, then we move on with our presentations after these fantastic 3 presentations. I enjoyed so much, guys. This was, I see Don Golding is here with us. Hello, Don.
Hello, Don.
And we have Howerd Oakfoard, a fantastic. I call him always my professor, and he tells me, no, I am not professor, but of course he is. And he will show us Colorforth, something that we all love to know. And I think there was a great chat before this meeting. I regrettably did not see it, only just a couple of things, but the interest in Colorforth for this group and for all Forthers is giant. So Howerd, welcome.
Thank you. Oh, it's over to me now. Okay, Colorforth. I will share my screen. I have a PowerPoint. So hopefully it's still there. Can you see my screen with the PowerPoint slide?
Not yet.
Not yet.
Not yet.
Okay. The usual technical problems. Oh, we haven't. Yes. Usual human problems. I have failed to click the correct button. Right. Okay.
Now it works.
Good. Okay. So. Right. Can you see the screen now? Forth 2020 Zoom. It starts with. Good. Thank you. Okay. So. Colorforth 2022. What's new in 22? It should be. I tried to make it rhyme, but it's what's new in 2022. Whatever. Okay, so I published a new version of this on the 8th of April. I was aiming for the 4th of April, for the 4th of 4th, of course, but I was late because of coronavirus, which I'm recovering from. Not too bad in my case. Okay, so from the outside, you'll see that the Colorforth this year is very much the same as the last edition from 2019. But inside, it's changed a little bit. So you can see here, this is the start block. There's a few new things on there, like stacks, and serve is also an interesting one, which I hope to show you later. There's quite a lot more there. There's also the CHM function, the check MD5, and I've introduced MD5 in there. There was already access to a PC's hardware random number generator. That was already in the previous version, I think. It's certainly in there now. So there's also to add to that MD5, which is, I think, a very simple and powerful hash algorithm. Okay, so what is new in Colorforth CF 2022 is the font is now in ASCII order. So I've made some kind of attempt to join the rest of the computing world and do things in ASCII, sort of. Yes, you heard it right, ASCII. So I thought long and hard about this over the last 2 or 3 years, and I think it's the right thing to do. There's pros and cons. Obviously, the pros seem to outweigh the cons at the moment. So A is now 65 again, like everyone else thinks it's 65, not 5. This is the internal Shannon-Fano encoding system. You can see that's the bit pattern, if you like. The count is 5 for an A. And the A is, of course, lowercase. Uppercase, lowercase is not something that exists internally in Colorforth. There's an uppercase A and there's a lowercase a in the font. Anyway, so ASCII, there you go. I've gone that route now. It has various effects. One of the nice positive outcomes is that in the assembler source code, if you want to have a string that you present in Colorforth, then you can use a quote mark and type a string. And this makes life much easier. So rather than commaing in 5 678 for ANIS or something, you can comma in a string ANIS. So when you read the assembler code, you can read what it's going to display on the screen. And I like that correspondence. So it's something you lose if you use some other encoding scheme, because the assembler source file is a normal text file, and the text file is ASCII or UTF-8 or whatever. So the rest of the world is using ASCII, so now I'm sort of using ASCII, but only for the font. But I'll explain more about that later. Okay, I've been adding to the documentation. It is not yet perfect. It won't ever be perfect unless I live to be infinitely old, I suspect, and that's not going to happen. I took a look at the task, the cooperative multitasking system, and I want to thank Josh Grams for his work. I routed through my Colorforth archive, which is quite a large archive of everyone that's ever done anything in Colorforth. I put it there, and I found a version of Colorforth that he produced probably 15 years ago or 10 years ago, and in it he had documented how the cooperative multitasking system works. So I used that, and I copied his comments, and I reorganized it. It always used to have three tasks: the main task, the drawing task or the show task, and the serve or server task. When I never really understood what the server task was for until I found some other code that indicated it was used to run a loop that looked at a port, maybe a comms port, and could handle something in the background. Very useful. So I added a fourth one to these because it's a nice round number in fourth. And the purpose being I want to have one for comms and one for Ethernet. So the tasks are there, but the code in them is not really there yet. That's still to be done. Because I realized that we now have 4 tasks going on, there is always a risk that if you write code that sets something going in a task that is not, how can I put this, it doesn't behave well with regard to its stack, then its stack will either grow or up or down if you put an extra item on the stack every time around your main loop, or if you take something off. After a while, the system will just crash, obviously, because its stack will overlap with somebody else's. So I added this very simple functionality that I've seen done lots of times before. But what you do is you fill the entire stack area with U's, in this case, ASCII capital U, hex 55. So when you dump the stack, you can see that if it hasn't been touched, it will still have a U in there. And then this little app stacks, walks through the entire stack area and looks at groups of 8 bytes. And if they're all U still, then it puts a U, and if it's not, it puts a dot. So I can show you that in action soon. And it means that you can see how far each stack has gone. And it was in this way that I found I had an error in a very fundamental word, type, as in I want to type n characters from address A onto the screen, was leaving an extra item on the stack every time. And so anyway, I found this out because the system crashed after half a minute or so, after I'd made this change. And so I did this so I could find out which stack was going wrong. Okay, and then this new word, check MD5. I got the MD5 assembler version for x86 from the internet. There are all sorts of versions. It took a few hours to make it assemble with NASM instead of whatever ASM it was using, and I had to fiddle around a little bit, but it worked. It actually worked more or less first time, which I was very impressed with, because I used it to check the first 64 blocks of the system, because you can always recompile the kernel, if you like. It's in the first 64K of the target system is the kernel. So you simply recompile everything and you'll get the same kernel every time. So you can archive cf22.2022.nasm, which is the assembler file. It's a single file. It's coming up to 8,000 lines, which is rather large. But you can always get that back. So if something goes wrong, you can just recompile. But the 64 blocks, 64K of the system, which contains things like dump and color definitions and the logo when it powers up and the millisecond timer, all these kind of things, important system functions. If you accidentally screw that up, because bear in mind in the target it's RAM when it's running, if you then save your system, you can have a broken system. So I thought it would be very important to know if the Colorforth end of things, the system, the 64K blocks, was still correct, what it should be. So if you simply type the word CHM, check MD5, it shows you a dump of the 16 byte MD5 hash, and it says something that looks suspiciously like EuroPC. Now, I have these kind of in other programs that I use. I have something called numname, which I I may have explained before. But what you do, you take the MD5 of your entire system, and you take two 15-bit chunks of it, and you look up two English words in a 32K word list. And this you'll find all sorts of my programs. For example, CF 2022 is called sparsely skated. I believe I've got that right. So that is an English expression of the MD5 hash of the entire image. This is the image you copy onto your USB stick. So this means if I find a Colorforth system, I simply do the MD5 hash, look up these two names. It's all automated in a program. You can use my Seaweed program for this. It will give you the numname hash. Anyway, so that's something that's been around ages. I've always hated this numname thing. It's absolutely horrible because it pretends that English words have no meaning. And when I was doing this, I removed from the list of words all the really horrible words, because you can, ever so often, it will come up with some really hideous phrase with these two English words. I won't give any examples, just think of the two really horrible words in English that you can use. Anyway, those words hopefully are not in my list, so you won't get that. But you still get really sparsely skated. It sounds like it could mean something, but it doesn't actually mean anything. Anyway, so I've always hated that. So along comes Colorforth, and I do this check MD5 thing. And because Colorforth generally encodes characters in such a way that it's optimized for words, and the more common letters occur earlier on, have a smaller bit pattern, it means that you tend to get a reasonable number of vowels, and you tend to get something that you can read. So if you take a random 32-bit value, you will see something that you can read out, often as not. Anyway, there's 4 options, and one of those for the current system is this, what I'm calling EuroPC. So I cheat if the selection of 4 words in Colorforth doesn't look very good, not promising, they're all kind of hex numbers or something, I edit the system slightly. I edit a comment somewhere, or add a space, or take out a dot, and then see what it looks like. So there's a little bit of artistic what's the word, improvement going on there. Anyway, so I don't need numname with Colorforth. This is really weird. Anyway, so earlier in the Forth Cafe, Dimitri asked, what's it all about? Why am I doing Colorforth? And I've never really thought about it, but when I was preparing this PowerPoint for this chat, I realized that the main reason is, oh, sorry, let me skip past that one, that I'm programming a PC or laptop as a real-time embedded system, because this is what I normally do. I used to do what you might call hardware real-time embedded systems, but these days it's all embedded operating systems type things. But the principles are the same. It's just that generally, if you're programming it under Raspberry Pi with Ubuntu, the Ubuntu guys have done quite a lot of the hard work for you, so it makes it easier. But I've always liked the idea, I've got all this hardware lying around. I've got laptops and PCs of all different sorts. And I like the idea of programming it as if it's hardware, as if it is possible to understand it as hardware, and you don't have to understand it in terms of operating system calls, not knowing what they really do. Okay, let me go back to the further point. Okay, so this is a quote from Chuck Moore from his fireside chat. You can actually see the video there if you want to on YouTube. So, and Sean, the interviewer there, or the guy asking a question, I should say, why do you think Forth has failed to go mainstream? And I just love Chuck's answer. You can just read that, but the bit is, I don't think there's any need for Forth to become a mainstream language. I think it's a very excellent niche language and a personal language. It can be used to advantage by people like us without requiring that the whole world would give us permission. Now, I really like that. It hadn't occurred to me, but people are asking, why am I doing Colorforth? The answer really is, of course, why not? There's no need to follow everyone else, and maybe something interesting or good will come out of this. I'm optimistic that it will, but it's a long way ahead. Okay, so that was one I just talked about. So let's make it real hardware. It's just hardware. There's interrupts, there's things going on that you can write to, and there's input ports, output ports, and so on. That's what hardware is. No operating system. Okay. The problem with not having an operating system is it's not easy to lock users in and charge them money without an operating system. I mean, you look at Microsoft, for example, it's not accidental that Bill Gates is quite well off. He came up with a really brilliant idea, him and his colleagues back in the early 80s, I suppose, or even earlier, that if you can define an operating system that you port to different hardware, you can like fuse together lots of different hardware environments with the same operating system, which will then run lots of different apps, as they're called these days, on top of it. And you charge everybody. Everybody has to pay. So it's great. And I don't have a problem with that. I use Windows. I'm sorry to say, but I do, because that's what I use at work, because I'm given a laptop. That's what's on it. Okay, no file system. Well, again, it's not easy to lock people in and charge them money without a file system. Because where are my files? I mean, it's getting hard to answer that now. It used to be that it was on a piece of hardware that I had. It was on a USB stick or a floppy disk, and I could pick it up and hold it. I don't know if, can you still see my picture? Probably not. Anyway, I will hold up a floppy disk later. Okay, there's no version control system in Colorforth. And I really miss it. I want a version control system. When I say there isn't one, there is one, but it's so horrible that I want to improve it. My version control system is that I run Colorforth in Box, and Box picks it up from a file, cf2022.img, and I archive it. And I archive the assembler file that is used to create the image, and I archive the Colorforth blocks that are also used to assemble the final image. It's 50% the kernel, or 64K kernel, and 512 less 64 Colorforth blocks, of which the first 64 are the system. So I really want to do a version control system, and it's really not easy, particularly with no operating system and no files in Colorforth itself. So this is my question. The thing is, I don't know how to do this yet, but I don't know how to do it yet. There has to be a way, and the way is to connect it online, obviously. So I don't want to have files on my system. I can do that. I thought about putting a FAT, file allocation table, file system into Colorforth at one point, and I've got some prototype images that do that to a certain extent, but I haven't gone that route yet. We shall see. So version control, the challenge is on. Okay, where do you store everything? And the issue here is, for example, I've got a whole archive of Colorforths that people wrote a long time ago, and they're in the form of normal files, obviously. Where do I keep all this? How do I access it? So think Dropbox, OneDrive, Google Drive. This is where my archives are on Dropbox. They're probably on OneDrive as well, if I could work out what got there and what didn't and how to get it if it does. And anyway, they're online somewhere, so that if my laptop or the hard drive dies, I can always get it back, which is very useful. Then once you've got it online, how do you get it up there and get it back again? Internet, obviously, and I'd like to use UDP/IP and not TCP/IP. And this is partly, I think, in the first part of this development process, its important aspect is that UDP is a lot simpler than TCP. But the main, that's the real reason is that TCP/IP, I think, is a horrible protocol. I know that it's used for everything. I know that it works. I understand it reasonably well, and it's just completely inappropriate for a Colorforth system, shall we say, where everything else is so neat and elegant and the simplest way of doing it. Okay, so having decided how to store it and decided how to get access to what you've stored, user interface. I've used these sort of things all the time. At the moment, I'm using Git. I've used Tortoise SVN, which I like. I think of all of these the best. I use the Git Windows Explorer interface quite a lot, etc. Not Git, it's too complicated. I keep coming up against Git with its staging, and I'm sure it's absolutely fantastic for developing things with 1,000 programmers worldwide, where you have to keep everything under control. But for me, it's way too complicated. So I have to work out some sort of user interface. So the user interface, CF 2022 needs Windows, and I don't mean Windows with a capital W. I mean Windows in the sense that you need to be able to write to a part of the screen and not affect other parts of the screen. This is pretty obvious. Colorforth at the moment actually has two words, LM and RM. And I saw these many years ago, and I sort of knew what they did, and I never really understood exactly how absolutely beautiful and wonderful they are. They are left margin and right margin, and I'm sure other people must have invented this, but this is the first time I've seen this implementation of a windowing system, which is so simple and elegant. And how it works is very simple. It's used, for example, in the keypad, which is a tiny section of a Colorforth screen. And to draw the keypad, you set your cursor to the line that you want. That's the leftmost column of the entire line on the screen. So say it's line 16 or something, whatever it is. And you set the left margin to the coordinates of the left part of that, and the right margin to the right. And when you send something to the screen now, it checks whether it needs to move to a new line when it hits the right margin. And when it hits new line, it does a carriage return and moves back to the left margin. So it's incredibly simple. So the problem has already been solved. So I need to grasp how that works more and sort it out. The only way it's used normally is that there's a word text which sets left margin to the far left of the screen and right margin to the far right. Then you get a full screen, and then it's used with LM and RM when you want to draw some window. That's what this is, a window. But it's incredibly simple, and when it's combined with the fact that Colorforth automatically updates everything all the time, it makes life very easy. Right, okay, we need internet. So the Ethernet port is relatively easy. There's even some code in there. Wi-Fi hardware and USB is relatively hard. Well, I won't go into details why it is, but it's something that I don't really want to attack. Like, for example, I'd like to give Colorforth a mouse, and that excuse me, that is extremely hard, and I don't want to try and do that until I've got the version control, and I can't get version control without internet and Ethernet port. So there's a route through, there's an optimum route to make it as easy as possible. Okay, so UDP IP is relatively easy, and that we already have code. Somebody did some code for that. I don't know whether it's Chuck or somebody else, but that's already in every Colorforth system for the last 15 years, I think, has that in. But I still haven't managed to connect it to the Ethernet port. I need to understand the hardware more to do that, and I need to set up a system with an Ethernet cable to something else that has Ethernet, and there's a lot to do. And it's not easy when you're doing everything on a system that doesn't have version control. Anyway, okay, that's just my plan. Yeah, and don't even think about TCP/IP. Right, we need crypto. We need to encrypt things, obviously. MD5, I just picked up off the internet, popped it in, a couple of hours work. SHA-3 is available for VolksForth, and all manage, these entire suites. There's quite a few. Kekak, I know Bernd Python, I think, has that, and there's various versions in VolksForth. And if there aren't, they can be ported from C or Python or something quite easily. That's why CF 2022 needs ASCII, because I need to be able to import conventional text files. I mean, I don't know how far Colorforth will ever be VolksForth. Who knows? Anyway, so that was one of the reasons I decided to go the ASCII route. Okay, the possibilities are endless because Colorforth is infinitely powerful, and I'm just going to go very quickly through some little things I did for the Kustentreffer, I think it was called, in Hamburg some years back, or near Hamburg. I still want to shorten the conceptual gap. I want to get the gap between the computer and the human brain closer. So these were in the file I copied, the PowerPoint, so I thought I'd leave them in just to show I want to get that gap down so that what somebody sees on the screen corresponds as closely as possible to what the computer is going to do, so we can understand it. And these things here, the conventional text file that you're seeing on the screen has to go through a compiler to produce output before anything happens. I'll just go through very quickly here. And, so it has to work out what a colon means. So one of the really good features about Colorforth is that it's pre-parsed. So the squared red name here is a red token, meaning it's a new name. So the compiler doesn't have to work out what it means. It knows it's already part of in the block. The editor can then choose how it presents on the screen what is in the block. So the Colorforth is all about the blocks of code, where the block is 256 32-bit tokens of various colors, if you like, doing various things. So, for example, the same block here, unchanged, can be used to present the code in a different way with the colon. So I go alternate a few times, you'll see what I mean. And then equally, you can change it a few times into a different language, a human language. And the point of this is that you can you split the presentation of the source code for the human reader from the block, from the code. And I think this is a very important concept, which I haven't seen anywhere else. So I think that's it. Any questions? I will unshare my screen if I can.
Why didn't you choose to use a circular stack? Or did you?
Yeah, I would love to. Everything, the entire Colorforth system, the assembler kernel, uses the stack. It uses EAX as the top of stack, and it uses ESI as a pointer into what you're seeing, or think of it as a stack. And so every code word in the entire system would have to be changed to point to something else. I would love to do that, but maybe somebody can tell me that there is a version of increment ESI through an 8-bit value or something like that. That would be very nice, but it's too much work. So I haven't had the particular reason to do it yet.
I was very interested that this last month in Colorforth that I downloaded the free version for the IBM, where it used the registers that you were talking about. And I just wanted to understand, not being have a great memory and stuff. So I brought it into an editor, and I replaced all the registers with what their functionality was in the Forth, so I could read the algorithm of the of the assembler, and it worked pretty well.
Yeah, that's good. I've already gone some way to do that. I don't use EAX and EBX. I call them top of stack and scratch.
Yeah, there you go.
Yeah. So that's already there. I haven't gone any further than that, I don't think. You could rename ESI as stack pointer, but yeah.
Yeah, I'll upload it, and then maybe I made a couple of mistakes or something, and people can edit it. But it kind of allows you to take a look at Colorforth's inner workings.
Yeah, that's great. Yeah, that's great.
In a more human readable for us non-assembler programmers.
Yeah. So I mean, I hate the fact that the assembler file is now coming up to 8,000 lines. It's way too complicated, but I mean, I've gone, yeah. Every time I make a change, I try to think, is this the right thing to do? And I've thought about this ASCII change quite a lot. I believe it is the right thing to do because I want to allow people to enter text in Colorforth from the keyboard, not the keypad. I know there's been lots of complaints, and I've added a function F5 that will theoretically allow you to do that. I haven't finished it yet, I'm sorry. Maybe Colorforth 2023 will have it in, or maybe if I get time, I'll do it.
You kind of describe the multitasking a little bit in more depth. We're going to be implementing multitasking on the Core 1 project here pretty soon. I have a bunch of different ideas. I'm curious about what your thought. Like, if you had a perfect multitasking system for Colorforth, what would it look like?
It looks like the one that's in there. It's the one that Chuck did. 21 years ago, whatever. It's very neat. Let me share my screen, and I'll show you what the Colorforth multitasker is. If I can actually close the PowerPoint show, and then my poor little laptop might have a chance of running. Okay, let me now share my screen. Okay, can you see my shared screen?
Yeah.
I'm just trying to find the task that is called main. Okay, so this is the cooperative multitasker, and you see there's a bit more. Oh, I'm saying it has 3 tasks. It now has 4. So first you define the a place for holding each task. So this is main. There's a screen task, a server task, and a server task 2. And here's the word pause. Here's the word resume, which used to be called unpause. And these are where the cooperative task round robin is defined. So what happens is you store where you came from, your stack pointer, in the location for each of these tasks, and then you call resume, which gets the next stack pointer and unstacks it all to what's the word? Get back to the state where you were before. And then it calls, main task, then goes to the draw task, and then the server 1 task, server 2, and then it jumps back round here. So that is it. That is the multitasker. Well, there's a bit more to it. You have to activate. So you have to store and what's the word? Configure a task so that it has its own stack. And then this activate, I don't think is anything to do with the conventional high-level forth activate. I'm not sure. I have to dig into it a bit more, but because this sets up where the given tasks stack actually is, it actually explicitly sets it up, and all it then has to do is to say where its program counter was. I think that's it. So it's very simple. So then you have a show word. This is the word that is called from the high-level Colorforth, which takes code following it, and it does all this thing. The show task has to do something else. It has to copy the screen image. Okay, let me show you something real in Colorforth, and I should have in here. Somewhere here. Yeah, I'm sure I had the window open, of course, and I can't find it now. So this is, if you download CF 2022, you and unzip it somewhere on a Windows PC, and I'm sorry it's only Windows. I might have to seriously think about going away from Windows. Anyway, you just run the go.bat file, and this loads the box emulator, which allows you to execute a program in a virtual machine. So it emulates a virtual machine. It still thinks it's booting from a floppy disk. In fact, it's a USB disk now. But eventually, it comes up and says, "Do you want to go full screen?" You do yes, and there it is. Right? Can you all see that now? The colorful screen.
Yes, perfect.
Yes. Oh,
Yeah,
good.
fine.
Good. Okay. So, by the way, for anyone who's coming to Colorforth, I don't know whether I mentioned this, Ollie, that you can use the arrow keys.
Ah, great.
So every time you click the down arrow, it moves to the next meaningful thing. God, it's very slow, of course. Right. So what I wanted to show you here. One more, maybe. No, too far. Okay, so this is one of the new apps. So if I run that, what you see here, the word TT serve 1, that's test server 1. It calls the word serve 1, and what serve 1 does is it sets the program counter, or the what do you call it in Colorforth, whatever it is, the place that the code is going to execute to the next Colorforth word. So it's going to execute what you see on that line there, and then when it hits the end, serve 1 will then do a pause and move on to the server 2 task, and then server 2 will move on back to the main, and main go to show. So what you can see here is that these two counters are being incremented, var1 at 1 Hertz and var2 at half a Hertz, except they're not quite in sync. Oh, anyway, on a real hardware, it works perfectly and very, very accurately. So because these tasks are now doing something, if you do stacks, this is also one of these new words. Okay, what you see here is a view of the used and unused area of the stacks. So you can see they're not very, very used. And if you refer to the assembler documentation, I should add some comments here really, that server 1 is, I think, at 7,300 and a bit. Looks like somebody's gone above that for some reason as well. Anyway, if I go back here, and if you have to be very careful here, because you have to turn things off before you start changing code, or it goes terribly wrong. If I do TT stop, like so, they will now stop counting. And I have not done, what am I saying? What I haven't done is called KSV2, kill server 2, or KSV1, kill server 1 in there. I use iServer1 because iServer1 is a system word that sets the program for server 1 to a default no-op loop. Whereas KSV1 also is doing exactly that, but the KSV1 exists in the dictionary. So if you do empty at this point, server 1 would be trying to execute a null loop in code that was no longer there. The system will crash. So what I wanted to do, and this I haven't tried this before, so I don't know whether this will work. If I in the loop here, if I add an extra, oops, not there. It is very hard when it's so slow. First, add something at the end here. If I add a green number at the end, 1, 2, 3. Right. Okay. Now, if I do empty, very slow. Okay. And then I do LL.
Howard?
Yes.
After you, we have Bill Ragsdale, and I don't know if are you going to show us in next meeting second part, or?
Yeah, I'm very happy to. There's a lot more to show. Okay, what you'll see happening now, this is now going to be adding 123 onto the stack of server 1. So if I get back quickly enough to stacks, yep, you can see there's more used stack space around the area for stack 1. So if we wait patiently, you'll get even more dots coming up. Right. Okay. The other thing I wanted to show you is the check MD5, which is extremely quick, and this is where you see the Euro PC word here. So if you see that, you can be confident that your system is exactly how it was. And if I go back to block 64, it's painfully slow. But Okay, so if I now add a word here. Okay, you have to wait for it to write. Okay, and then I come out of all this. And I do CHM again. Sorry, mistyped. CHM. I can type about 10 times faster than it can display. You'll now see that this is now Erunu. So that gives you a new word to know that that's something has changed. So if I do UU, should be CHM. It comes back again. So UU is undo. It's like undo your text edits. So there's all sorts of very nice features here. Oh, I've added icons. I've added to the functionality of icons. And I said, yes, I wanted to show people this really is ASCII. If you do icons on a previous system, you'll find that a 4 is not a hex 34. It's something else. I can't remember what it is. So I've added this, and I've given an overview of all the font characters there. So one of the fun things you can do, because this is kind of all real time, is I can go up to a line here. Now, if I go to the left arrow, okay, not too far again. Right there. Okay. Now you'll see that this character is used in the keypad on the right there. So if I now edit it, which I can do with the icons app, I simply go this way to the right. I'm just adding lines. You'll see that. Oh, sorry. Under box with my poor laptop there, it will crash. But I hope you saw the actual icon in the keypad had changed. It will just take a while to come back again. Right. So just do that again.
This is something people should remain. We are not running on a real system, but on a simulated, on a emulated.
Yes. Well, what I wanted to do actually is show you a real Colorforth on a real system, for which I have a camera.
One of the questions I have, if somebody wants in a modern laptop to insert a pen drive and run it from the pen drive, it's not possible anymore because of the UDMY, or is it possible?
It is possible. I'm doing it. It's getting harder and harder. And I did make a comment a couple of years back, around 2019. I said that this Colorforth is only for the window of time until this all these computers get locked so hard you have to do something else. And I couldn't, for example, I couldn't run Colorforth on my old Windows 7 laptop. It would not boot, and it's a bit of a fight to get it to boot on this PC, but that's because it's got a funny BIOS. What I wanted to do quickly is if I stop sharing the screen and share the other screen, which is go to the other camera. Okay, how do I get you to see it in full screen mode? How do I share my other camera? Or I'm not sure how to do this in Zoom. Can you see my screen? I think it's down to every viewer to make it full screen. Or is there some way where I can force everyone to see it?
Oh, we can. So where are you there? Howard, let's see, focus for everyone.
Okay, oh, that's good. Okay, but now I need to get the right camera. Okay, sorry guys. I've got a background screen on there. Look.
Yeah,
close.
You
okay.
have to remove the virtual background.
Remove the virtual background. Sorry. Yes. Choose virtual background. None. Yay! Right now. Okay. This is the best I could do with my camera, but this is a real Colorforth system. It's running you can see one of the things Colorforth does, it uses. Of course, the computer has just crashed. Just a second. Obviously, I had it running all day. Bear with me a second. Right. Okay. Yes. So the camera here is a very interesting camera. It cannot cope with bright Colorforth characters. It gets them very blurred. So this should be rebooting Colorforth. It doesn't take long. So it's a conventional BIOS boot, but it is going to.
Howard, in the meantime, there was a question of Dimitri waiting. Dimitri, just go ahead and ask Howard. If Dimitri, I don't know.
I am here, but I don't. Oh yes, I remember the question now. Yeah, I actually forgot the question in that time. Yeah, it was. So I get your point about why you do Colorforth. I mean, a person can work on anything for any reason they like. But I guess what I was trying to get to really is, why might somebody else be interested in Colorforth? What are some of the advantages or interesting things that you can do with it?
You can do whatever you want with it. So this is one of the interesting things. I know that cooperation is a big part of the way the world works. That it's like I don't make my own laptop, for example. I use the ability of the commercial environment to I just buy one. So you don't have to do everything yourself. In Colorforth, you can do everything yourself. There's everything that you see here is enclosed in the zip file. There isn't anything else except hardware.
Dimitri, it's a bare metal force.
I see. So good for if you want to do bare metal stuff.
If you want to understand how things really work, because my observation is that the commercial environment is one where a company has to make a profit, obviously, and that's right. They have to, when they decide to do something one way or the other way, they have to bear in mind how much profit they make. And when you buy an operating system, or you buy a laptop with an operating system free on it, there are reasons why it's done that way, which are not to do with what is the technically most elegant way of doing it. I mean, for example, you can't use the simple cooperative multitasking system that we have in Colorforth in a commercial environment on a laptop, because any one task has to do, somebody has to say R/from, press the enter key or the space bar, and the whole system will fall over. And that's not good. There are ways of working around that, but there is no commercial requirement to do things in a simple, elegant way. People want to make things more complicated. They want to get people locked in. If people weren't locked in, then you could take your Win32 program and run it under Ubuntu or something with no changes. But you can't do that because people have decided not to make the system calls exactly the same, and that's fair enough, and I can't say it's wrong. But anyways, while I have real Colorforth, I wanted to show real Colorforth because I want to see how quick it is normally. This what you're seeing in the box isn't right. So going back to icons, so I can type reasonably quickly, but you see the sort of things you can do here. So if you want to create a new icon, and there's a few here that I made myself for the little computer game that's in here. Okay, so there's the loudspeaker on and off symbols, and there's the the little characters that move around, these two things, arrows, whatever. So you can you can edit this very easily. So what else do I want to show you? Oh yes, and one of my favorite apps that I could show you running in real time is int. Now what you're seeing here, this is the PC's interrupt. I mean, I don't think anyone who programs these days even knows what an interrupt is, probably, but this is the pin or pins in the hardware, actually embedded inside a huge chip these days. But it used to be an individual chip with individual pins that you could put a scope probe on. When that pin is taken low or high, whichever it is, some other part of code gets executed until it hits an IRET, and then it comes back. And what you see on this screen is code to configure the programmable interrupt controller, the PIC, and the PIT, is that programmable interrupt timer or something? And it's all very cryptic as to how it works. But what you see there is a timer interrupt that's going at 1 kilohertz. You can see the 60, 61, etc. to, well, it may not be exactly 1 kilohertz. I don't know, but you can configure it to whatever your frequency you want there. So this is the interrupt, and if you turn interrupts off with a CLI, they stop, and if you turn them on with a STI, they start. So yeah, so that's oh yeah, I want to play a tune to you all, which you can't do under Box. I don't know whether you can do it under VMware. Can you hear that?
Yes, yes.
You just hear, I'll just do it again. Oh, maybe I won't do it again. And I just wanted to play that because this has been in the system for at least 15 years. But I've not heard it very often because I don't often run Colorforth on real hardware that really has one of those little speakers in it. And the interesting thing about this is, if I go to, where is sound? Sound is 114, so 114 edit. And you can see I can type extremely quickly with this. It takes a little bit of practice, but it's not bad. So what you're hearing there is the word HH. This is for handle. It's playing Handel's Gavotte. And I use this piece because it only uses exact major thirds, major fifths, major fourths. So the calculation of the tone means that it's perfectly in tune. It's not an equal tempered scale that approximates to one 12th of an octave or whatever. So I don't know if you can still hear it because I'm not near the computer anymore. But in theory, it's exactly in tune. And there's various other things I can do. I don't know how much you can hear now.
Is that the whole piece on screen right now, or is there other screens?
No, this is the whole piece.
Amazing.
Can you hear this one as well? This is, yeah. It's a bit slower than I intended. So what you hear here, if I do H1, for example, is that, and then H2 is that, and then H3 is that. So I could go on with this piece, but I didn't get any further there. So HH is just playing all of them. Or you can call it handle. I made a short form for it because I didn't like to type handle all the time. But that is it. There isn't anything else except the documentation screen here. Oh, so.
Amazing, Howard. This is an amazing presentation.
Oh, thank you.
then we follow this next part in the next meeting in May.
Okay, I'll be happy to explain a bit more about how things work internally. This, by the way, is Chuck's color creation thing. The colors that you're seeing, or I'm seeing on my laptop screen, are pretty bland and washed out compared to the real ones. So very nice colors there. But so there's all sorts of things that are wrong with Colorforth. There's no doubt about it. It needs Ethernet. There is an Ethernet Eth, it's called. I don't think it's doing anything that I understand yet. Oh yeah, let me show you while I'm showing these real applications. RTC, the real-time clock. Okay, this is a display of 16 of the real-time clock registers. This is what every PC has. And you can see the lowest one, 0, is the seconds. That's ticking away there. Next one up is something else, a day of week or something. I'm not sure what the order is, but the date on this PC has not been reset since 2003. That's what it defaults to. But you can see that it's counting up. So 1st of January 2003, 10:56 and 42. 42 is the week. Interesting, because nobody's set that up since I turned it on. It's gone haywire. Okay, and I use the real-time clock. If you look at register 12 there, you see there's a 40 and it blinks. Oh no, sorry, register 10. There's a 26, and you can occasionally see it flash on the screen there, and that's because the top bit is pulsed for a certain length of time when the clock updates internally. And I use that in the timer thing. Here we go. So this is how I access the real-time clock when the thing powers up. RTC fetches a value from one of those 16 locations, and high fetches the value from location 10 and waits until the top bit goes high, and low fetches it and waits till it goes low. So when you do cal kilohertz, C-A-L-K-H, fiddly one to type actually. There's a pause before anything else happens. Oh, and it's crashed. Good. Okay, with that, I think it's time to turn that off. Any more questions?
Yeah, I was fascinated with the computer booting into Forth, and I tried several systems with the original boot floppies, and none of these worked. So I analyzed the Colorforth to death, but in the end, I booted my computer intelligence Forth, and that succeeded, but only for a short time.
Yes.
And then I abandoned the idea.
Yeah, I would say thank you very much, because I believe you were involved with John Como, weren't you, with the doing something with different Forth that you reconstructed, reverse engineered. Anyways, there's some code.
Yeah, I reverse engineered the original Colorforth when there was no assembler available. And to this time, I have a C as this reverse engineering assembler, that resulted from this effort.
Yeah, I actually went from Chuck's sources when he published them, but I found your your code has extra comments and more information about what was going on. So I found that very helpful.
Thank you.
Oh, thank you. Okay, any more questions? Just to say, it is getting harder and harder to boot anything onto a laptop these days.
Christian has a question.
Okay, hi, Christian.
Hey, last question.
I still have my old Colorforth floppy disk, and I'll boot it when after your presentation. And I would like to know how similar your Colorforth that you've been discussing today is to the original floppy. In my case, it probably goes back 15 years ago.
Okay, so 15 years ago is what? I don't know which one that was.
I would say around 2005.
Okay, I would say, okay, there's two major areas where I've diverged, shall we say. The first is the way CF 2022 boots up. It accesses the BIOS in 16-bit mode from 32-bit mode. So that means it can now be used from a USB floppy drive or a USB stick. That's the main thing, I would say. Then on the other side of that is the apps that are on there that I supply in the file. I've tried to trawl the internet or whatever. I find every Colorforth app I can, and I've tried to make it work on the system. And then in between those two, I keep making changes to the internals of Colorforth, and I've done some horrible things. I know Anton Ethel was a bit shocked that I went from Chuck's original 32-bit cell addressing mode. That is to say, if you put in 100 hex fetch, you'd get the 4 bytes at 400 hex because the 100 was used as a cell offset. And I went through and I changed that because everyone else does it as a byte offset, and I weighed up the pros and cons. And if I had known how hard that was going to be to make everything work again, I probably wouldn't have done it, but I'm glad that I did. And now, having gone over to ASCII, if I'd known how hard it was to change everything over to an ASCII ordered font, I wouldn't have done it, possibly, but I'm glad that I did. I think it's the right way to go.
Okay.
Yeah.
More, I think, next month. And
yeah, I'm
thank
happy
you
to
very
come
much
back
again.
and get
Yeah.
into more detail on how things work.
Thank you very much, Howard.
Thank you.
Okay. Yeah, clap hands. And let's proceed with our schedule. I'm happy to present Bill Ragsdale. He will talk about Forth meets Walmart. And thank you very much for your patience, because I know we are again way over time. So. Oh, you have to unmute.
Ah, good reminder. Very good.
Here we
That
go.
would have been a very silent presentation. Thank you very much. A lot of our presentations have been more on a systems level, Forth variations, Forth designs, Forth innovations, and so on. I'm going to drop back to just a plain old application. This is just making Forth do something. And in this case, we're going to be simulating the self-service terminal at a Walmart store where you scan your purchases, put in, get a bill, put in money, and get change. So you see the outline here. We want this change maker to take charges from a penny to $100, accept cash. Upon the entry of currency or coins, show the balance due. And then finally, if change is due, output the values. And of course, the change machines have a number of control mechanisms. So they have to be able to dispense independently pennies, nickels, dimes, quarters, $1, $5, $10, $20. And we ignore the US $2 bill and we ignore the US 50-cent piece. So here's what it actually looks like. This is the actual US version of the Walmart self-service terminal. On the left, we see coins going in to pay. On the right top, bills going in. And then if you have a change due, it spits bills out the bottom and coins out the bottom. And I found out this machine does take $100 bills. So if I need to break a $100 bill, I can go down to Walmart and buy a stick of gum and I'll get full change for my $100 bill. So this is a program in words. What's it supposed to do? Well, we have some values, that is Forth values, variables. One of them holds the money values and another set holds the change component values. And we accept the user inputs. We net out the inputs and the outputs, determine if a change is due or if more money is due, and then keep the user up to date. This is the overall program. This is the begin again. It will start, it would run indefinitely. So of course we do a new transaction. We then ask for the charge that is due from the scanning, process the payment that the user puts in. We bill the change if necessary, and then show the change output. And then showing the change, in this case, these are command structures or command elements that go to the mechanical change dispensing items. And then finally, to be able to end this program, we have a goodbye selection with the escape key. But of course, in a normal change machine, you would not have any escape mechanism. These are the value components. I use values mostly these days as contrast to variables because they're just more convenient to use. And the first values are the amount of the sale, the amount the user tenders, any amount due from the user, and any change due to the user. And then finally, we keep track of the change by the coin values or the bill values. The two top level commands, one is to ask for a charge. So in this case, on a demonstration basis, we are typing in what the charge is. In the case of the ask for charge, this would go to the scanner saying, give us the total of scanned purchases money due. Then we ask the user, please enter your payment, and then accept an input from the user. This is a simple begin while repeat structure that processes the payment. It asks for the payment, it nets out the transaction, and if more money is due, the while command then says, please deposit more money. So we sit in a loop, getting payment, netting a transaction, asking for money, until finally we get either a zero or a negative balance, and the user input is terminated. These are a couple of the internal words. One is the process is a new transaction, and we see we're using floating point. So on that line, it says 0E to dollar value sale. 0E is zero floating point, which clears the sale. 0E to amount due clears the amount due. And then netting transaction looks at the sale and the amount tendered. It figures out if there's a balance due or not. F-scale, this took a fair amount of thinking, learning, exploring mistakes, and so on. And we'll see what the problem is at the very end. But what scale does is I've added into the system the ability to scale decimal numbers by magnitude. So if I use 2F scale, it will scale a floating point number, forcing the lowest two decimal values to 0. If I say minus F scale, it will scale giving me 2 fractional decimal points. I found this was necessary in handling money because when we start doing multiplying and dividing by floating point, you will often get continuing fractions and they don't necessarily round off conveniently. So this is essentially a way of doing rounding. that is appropriate for decimal numbers. This is the processor for the change maker. The build change command takes the change due and it factors it down and figures out how many $20 bills, how many $10 bills, how many fives, how many ones, quarters, dimes, pennies, nickels, pennies. So we're doing decimal arithmetic here, and you see the F scale value shows up on the second or third line. And so after every multiplication and division, we do an F scale to remove any rounding due to the floating point peculiarities. This could be done a couple of other ways with rounding. On the other hand, there are variations in rounding, and this is very precise, keeping us locked into a currency-oriented decimal system. And finally, the display the result. At the bottom line, you see the 2 pennies, and that takes the value that's going to be dispensed, and it does a little scaling, gets things in a right justified mode, and then displays the pennies that are due to the user in quantity and in money. The driving program for this, if show change, says first on the first line is if change due is 0, no change is due, and the program exits. Otherwise, it goes into the factored values and displays appropriate message for each transaction. In this case, the red lines now, of course, would be going to the mechanical change maker, and these would be commands issuing the values to spit out the coins. Here's a good example. So this is the overall running program. Remember, they begin again at the very start. The terminal says to the user, please, this goes to the, on a test basis, it says, please enter the cost sales. So I typed in $25.78, and then the program asks for payment. In this case, I entered 78 cents, and the system comes back and says, please deposit $25. It's netted out the 78 cents. Please enter payment. I put in $20, and it comes back and sees the net is now $5 dues. Please enter your payment. I enter $5, no changes due. In this case, change will be due. So I enter a $37.23 amount value. I put in a $20 bill, and it comes back and says, please deposit $17.23. In this case, I deposit another $20 bill, and it goes immediately to the change process and says your total change will be $2.77, and it'll be 2 pennies, 3 quarters, and 2 ones. The fourth has in it the .r command for integer values to do justification. The fourth I'm using, which is 132 fourth, doesn't really have any functions for handling formatting decimal numbers. You have to do it on your own. So one of the previous slides showed a routine that puts all these things, puts the $sign out, aligns things by decimal number, formats it printed. Now here was my discovery. This is a part of a trace routine during development because I was getting the wrong number of pennies. Very often I was 1 penny off in the change. So I did a trace showing what is the decimal value all the way through the 20s, 10s, ones, quarters, nickels, dimes, pennies. And I got down to the last penny, and I see that there was a floating point deviation in about the 16th or 17th decimal point, where it was deviating from 1 or deviating from 2. And of course, notice down it said your total change is 2 cents, and it actually only gave out 1 penny. So that scaling factor that I put in went in, and it solved the problem by keeping everything rounded to pennies. So summary. First, I choose floating point in this. I could have done it with integer values and scaling, but I chose floating point because in parsing keyboard input, using decimals, floating point is more convenient. If I had done my input money in integers using embedded decimal points, I would have had to parse each number individually. In this case, the parsing is done automatically by floating point. As I mentioned a moment ago, aligning floating point output took a little bit of work, but like so many Forth programs or all programming, once you develop the structure, the use then becomes very convenient. And finally, the last point was that floating point has the continuing fraction difficulties. And so I developed F-scale to do a precise rounding that was tailored just for, or optimally for handling money. So there we go. I've got to run. I don't have time for questions. This is a simple application. It's posted at GitHub. So if you go to my GitHub page under Bill Ragsdale, you can see the code for this. And so thank you all. I've got to run. We had a great meeting today. Very ingenious, very informative. Thank you so much.
Thank you. Yeah, great. Yeah, what a nice talk and a good application. And yeah, it's always a balance that you need to find using floating point or doing it with integer or scaled arithmetic. Right. So let's see where we are. Yeah, thank everyone, including myself, for the nice talks. And now there is this collective talk from Brad, Jos, Jan, and Peter about the things that are new and the ESP32 for development. And I don't know how you split this up. You just grab the mic and the screen and tell us all the exciting news.
Cool. I guess I've got, well, I need permission. Oops, I pushed the wrong button. I can do a little brief thing on some things that have been going on. Sort of the diff from the last time I gave an update here a bit ago. Most of it's sort of odds and ends, but there's a couple of things that, especially if you look at the history in the repository, well, these are the things we'll go through ever so quickly. One sort of high level thing that sort of glues it together, if you're looking at the commits going into the ESP32 Forth repo, a lot of the changes have actually recently been around the Windows and Linux support, and so are kind of irrelevant to ESP32, but there's a couple things that from that might be relevant to ESP32. This is a minor one. Someone filed an issue and asked for serial 2 support, and that's in there now inside of the serial vocabulary. Not extensively tested with actual hardware, but it uses sort of the built-in stuff, so should work. There's a few little odds and ends I had, for various reasons, left out. Unsigned 16 and 32-bit loads, and added those in because I encountered some cases where I needed those. Somebody flagged that I was missing question dupe. Not a big question dupe fan, but added it. There's also relevant to some of the graphics support happening in the other platforms, a fill 32 operation that got added that lets you fill a region with a repeated 32-bit value instead of a single byte. I added more floating point, again, mainly because it was relevant to some of the other platform work going on, but there were some of the trig operations and exponents that had been left out just because I wasn't using them initially, and now they're there. I think we're not fully complete in terms of what's in ANSForth 94, but getting dangerously close. There's some optimization work that happened on constants and variables and values. Previously, if you'd gone looking in the internals of the interpreter, there was some weirdnesses around do create, do does, and do col, and that's been sort of cleaned up. And previously, there was not a dedicated do con and do var opcodes. Those have been added mainly to and those were possible because of some of the work that had happened to make it possible to have built-ins that are immediate. And this allowed me to revise value to use constant and have do set. So before everything was in high level Forth, and now I've added, been able to pull over, now that there's sort of a vocabularies tag and a way to tag, able to add in some of these new opcodes, as I mentioned, and that lets me change the way that value is done so that it instead relies on constant in its implementation and uses do set. This has one nice side effect. Oops, sorry. Well, we'll talk about that side effect in a sec. There had been a bunch of sort of ad hoc weirdness around addresses of some of the opcodes that are referenced, and all of that's been sort of cleaned up, and now adder of is used throughout. Variable and constant are now built in, so that makes them a little bit more direct. And this has the nice side effect that C now is able to correctly disassemble things involving values in 2, and same with constant and variable, which was partially true before. Actually, if folks could ping in the chat sort of your opinions in the matter, one general thing I've been thinking about in the background, wondering if it's relevant to others or not, but I could make C higher fidelity if this is useful to folks, probably without making it that much more inefficient and so on, possibly by tweaking whether some of the branching opcodes are specialized. I think sort of pie in the sky, I've always liked the way Jupyter AceForth has nice disassembly, and I've done other Forths where there's sort of that pattern, but it takes a little bit of awkwardness to it. So please ping in the chat if you have an opinion one way or the other. For the graphic support that's happening in the other platforms, there's some structured support. I haven't turned this on yet for ESP32, partially because I'm not sure if it's relevant. Basically, there's a syntax for a lot of C libraries use C structures, but they have to be padded and sort of do proper alignment. And so I wanted something simple and Forth to take. This is mainly relevant for things like on Linux and Windows accessing structures that are in the system. You're able to declare a structure and then get the proper alignment and layout to come out, and then this lets you work with the types of built-ins that you have in or the types of structures that show up on platforms with a full OS, and then you can sort of access individual elements in this way. The implementation, I'm not going to bother with that in the interest of time, but it's a couple very, very small implementation. Again, I would be curious to see in the chat if folks think having structure support would be useful, if you've encountered situations where you wished you could access structure elements. I think in a lot of cases, for some of the things that we've created bindings for, there tends to be, if you need to access the structure, we've built in a binding to implement referencing the various fields in C directly. So it may be less relevant for ESP32 and on at least with the Arduino bindings. Just so folks know what's going on, if you follow the commits there the last month or so, been mostly graphic support for Linux and Windows. This might be relevant for ESP32. We could turn some of this on and have low-level support. The idea is that there's both a low-level and a high-level interface. Everything's sort of top to bottom done as much as possible in Forth. So there's sort of a low-level interface that lets you access individual pixels, flip the screen, and then it's some very simple event handling and access to fields like keyboard and mouse. And then on top of that, a slightly higher level interface that lets you draw boxes, and I have more coming for other higher level shapes. There's transformation stacks so that you can build up sort of hierarchical things, transform the scale, things of that nature. And so, you could have a hierarchical structure build up, the wheels on the car and so on. Would this be useful for ESP32Forth? I think that the challenge is that although there's displays that can be attached, they're each kind of a special flower. And this particular graphic system sort of assumes 32-bit, rather 20, RGB, 24-bit graphics throughout. Not sure that would be a useful facility. Ping in the chat if you think it would be. I will give a brief demo so folks get a sense of what the graphic system is capable of. So this is a demo that I put together for Valentine's Day with the FIG folks. And so this is all done, including the drawing of the shapes of the hearts, at the pixel level using the same core engine running for in ESP32Forth. And so all of those performance issues that we heard about earlier play a role in terms of how quickly this can happen, because it's doing all the pixel manipulation directly, but obviously running on x86 and so on. Are there any questions?
Hey, Brad, are you doing graphics on like a dedicated screen that's attached to the ESP board?
Sorry, this is, to be clear, this graphic stuff is on desktop. So this is the same engine compiled for desktop and then target. So all I'm getting from Windows or there's Linux support as well is an underlying frame buffer, and then everything is just being drawn into the buffer. So we could bring this to the ESP32, targeting obviously a smaller display or whatever you would attach externally. On the other hand, maybe it's not the right sort of thing to build into the system. It might be better to have this as a sort of a library sitting on the side, things like that. And it isn't something on Windows and Linux. I've built some of the pieces of it in just because it's there's not as much of a space constraint, but it's not currently all sort of disabled for you. So did that answer your question? Cool. I will check out the chat to see if folks had any strong opinions on the poll items that I'd asked. Thanks.
Brad, we have from time to time some questions from Jean Langevaad, from Christian, etc., about ESP32Forth on the Facebook group, and I think we are trying to resolve every problem when it happens. But it's an extraordinary development, and I am so thankful to you. And I think all the Forth 2020 group is very happy to have your work in use, no? In many projects.
I appreciate that. I appreciate that, and if anything, I feel terrible that I'm oftentimes slow at responding when folks ping me. My sort of workload at work sort of ebbs and flows, and I had a free moment when I did the graphic stuff back. Actually, a lot of it was actually late February, shortly after I presented the last time, and then I got super busy. So please, I will not be bothered if folks are more aggressive at pinging at things that aren't getting resolved. And I have sort of a running stack of things. If you file issues on GitHub, I occasionally go through those, but it's also something where it languishes for some time. So don't feel shy about making more noise if I'm unresponsive. It's not for lack of caring, but oftentimes just I get behind, and then it's hard to catch up. So.
I created this ESP32 GitHub. Then we create with it in the future. How do you know it? Name it. It's not the group, but what's the name of the GitHub when it's not a personal page, but community. It is a community. I did not change it to community, but that is the idea. Because in the past I was sharing into my Peterforth GitHub the things from the group, and I wanted to have it separated from my work. So we have a neutral GitHub. And I have great news. There is a friend of us from Spain. He's not in a meeting now, and he has started videos in Spanish for different forts. One is for ESP32 forts. He did his first video about installation. I will share it later with you on email, and the group has also the, I think it's on the Forth 2020 page I shared. But this will bring a lot of people into the ESP32 forts that don't speak English. And so we have now also an ESP32 force Facebook page for Spanish-speaking members and for Portuguese-speaking members. Of course, Matteo Vituri and other people from Italy can write in Italian if they wish, and all Latin languages, probably somebody wants to write in French. On the Forth 2020 group, I didn't have the possibility because people complained. They wanted everything in English, which is perfect. But some people are shy in other countries and don't want to interact in English, and this was a problem.
Excuse me, Christian, I have a comment for Brad. So Brad, I think you saw my question about—
Oh, the macros, yes.
Yes, I think it's probably way too complex to answer today, but for beginners, you're a master at using macros. And I think if we could get a summary of how you use it in a good way for us to now use your approach to create new words, it would help.
Yes. I think a ways back I did a very abbreviated exploration of it, but yeah, I think I overdue for a presentation on the topic. I'll plan for that for a future session. I think that it's unfortunately a little too much magic with some of those, but it's also nice in that it avoids repetition. A lot of C-Forth implementations I think end up having to sort of state the thing over and over, and I think I've found a pattern where in general you can have sort of one definition in one place in the C code for a word.
And maybe also a few tricks on how to access data structures that are within the Expressive API.
Yes.
I'm getting lost there.
Christian, you had a question about this XY macros, no? Is this the same stuff?
Yeah, this is the same. Yeah, XY, and I think there are a few more now, and they get redefined as well. So
Brad told me he was very busy with his job, and probably in the next months he can put this information in his webpage, and we all. It was also a question of mine about this XY macros.
But anyway, thanks a lot, Brad, for keeping us informed of the evolution.
It's exciting to see people using it, and the benchmark thing. That was great. That was great fun to see.
John is in the group, or is he leave? John, you have the fantastic MC 6800 simulator.
Yeah, can you hear me?
Yes, can you share some pictures on?
Yes, what has been going on? I'm pretty close to ending my project now. I only missed a little bit. I have the coding, but it has to work first. So I can show you where I am now. If I can get the screen, just a second. Sorry, share screen, whole screen. Yes. Okay. Can you see a white source file?
Yes.
Okay, good. And just a second, I will show you a little video first. Here we go. That is where we are ending up now. If it works, yes. Okay, what you saw was my emulator running, and the new stuff is that the lamps, all the LEDs are showing what is going on in the machine. And just to show you, I'm inspired by this one. This is the original Motorola 6800 machine, and that is my very first Motorola machine. But coming back to what is going on here, you can see most of you will recognize this line. If you have put it a few times, you'll see something like that. And I had one problem, that was getting enough memory. And Brad made a little miracle, and I got a lot of more memory. But in the end, I needed just a little more. So maybe I have more free bytes here than you have in your system. And that is because I have been into the ENU file and manipulated the size here. Brad has set off 100 kilobytes here on the heap, and I have adjusted it to 110 without problems, I hope. So, but I cannot keep on doing that. So I wonder where is the limit of where I can steal some extra memory. And what you see here is my own development system. And in this window here, I have my source code. In the other window here, the black window, that is simply the terminal. What I found out here in the end, when I had something like 15 files I had to load before the system is running, I had some papers on the desk telling do this and do that and remember that. And I found out that why not putting all those instructions to myself into another source file. So I'm now using the source file to make my own notes. So I've started to call them the manual files, and you can see I have a manual of how to load the program. Of course, in the end, it will be embedded, so it will start automatically. But now, when I do the development, I have to start all over. And you can see here, that's a command line here. I have more than 11 very big opcode implementation files. That is because there is something pretty close to 200 different opcodes in the microprocessor. So I use my own source manual system here to load. You see the first thing I'm doing is including the Altair stuff. That is a software that is controlling the LEDs and the all the switches on the box you saw. The next thing that is doing something, yes, just an important thing. When I have an include here, I will include this software, but that will include this one, emulator also. And this one will include 11 files. So it's a long nested file of loading forth codes into the system. So in order to show you the picture you saw before in the movie, you saw the screen was showing something from the computer, from the emulated computer. That is a complete operating system in the Motorola world. You have 500 bytes here, 512 bytes, and it's loaded into the memory location E000 in the 64 kilobyte RAM. This I do here when I init the Altair. I will get memory and load all the vectors and all the program from the MIG-book. I better tell you that the MIG-book is the operating system in the Motorola computer. That was one taking up half a kilobyte. And I have some comments here. And finally, I'm setting the program counter in the virtual machine to the entry point into my book, the operating system. And I show the status of the virtual machine just before it's running. So that loading all that takes something like 1 or 2 minutes because it's thousands of lines I'm loading. And in order to spare you for the time, I've done it already here. And I started by asking here, where are we in memory before loading all the software? And here we start loading the software. And now we saved 1 or 2 minutes here. We're loading all the software and copying the operating system into the RAM area, asking for a status, and we get a status in the emulated machine. And see the program counter is set to EODO. That's the endpoint in the operating system. Okay, now I can say, where are we now? We are here, and I've swapped the two numbers. And so we have the size, and if we ask in decimal, you can see the source has been compiled into memory, and it takes up something like 48 kilobytes. So that was why I had to expand in the INU file. Okay, I've asked here in Forth, still in Forth, but how have we set up the virtual Motorola machine? You see the program counter is set to the entry point, and we have some registers A and B, stack point, and so forth. So if I write one now, that is command that will start the virtual Motorola machine. So this prompt, this asterisk here, is the signal from the MIG-book operating system that I can enter some commands. I only have something like 5 or 6 different commands. One is seeing how are the registers, that has to be in uppercase. So that is the register A and B, and index point and stack point and so forth. You would see I'm working with the system. I can set an address, tell the operating system I want to dump out what do we have in memory. I would just make a short one. You see I enter an address, sorry, E002. That's hex address where I can enter a starting point. That is E150, E1BF. So now I have set some pointers. That's an address E150 and ending address E1. And one of the commands I have is punch, and now Motorola operating system will punch out the memory I set starting and ending address from, and that is kind of a memory dump, but it is in a special Motorola format. You can see there's an address here. I hope we stop pretty soon. Yes, it's stopping. You see, I asked to dump address E150. That is the starting address, and here is the content in the memory and a checkpoint, checkpoint byte or whatever you call it. Some checksum there. That is one of the commands in the processor, and you see it is running pretty slow. But in fact, what you see on the screen was what you got in the late 1970s. The terminal maximum speed for this operating system was 300 bits per second, 300 baud. And the emulator is not running very fast, but what is really taking up time is updating of all the displays. You see here, just reading all the LEDs and not pointing to the LEDs and checking for the switch is happening in a subtask. And when I'm doing the update of the lamps, all the LEDs, it is done in a multitasker and is read in by a 2-port 8-bit E²C extender. So that is working on the 100 kilocycle speed. I hope I can make it to 400 kilobyte speed, but that is the really speed limiting factor in the whole system. Okay, that was what I'm up to now. The only thing I really need is being able to enter programs when the processor has stopped and do that on the switches and make changes in the memory and start it again. But all the lamps and LEDs are working, just missing the very, very last part. Okay, that's about it. I better stop sharing a screen. So, yes, that was all. Any questions?
Very good, fantastic.
Thank you.
Yeah. A comment on the memory front. If you upgrade to a newer version, you should get a larger amount of memory free by default. It queries the system and tries to allocate sort of as much space as it can while leaving a big enough buffer so that the ESP internals are able to sort of still operate. So hopefully that will give you a little more headroom.
Okay.
Yeah, that was very interesting. The
Thank
whole
you.
meeting was great. I have to go have my supper.
Bye bye.
See you next time.
Bye bye, Howard.
Bye.
Cheers.
See you next time.
That's exciting. The physical switches and whatnot just look that's absolutely beautiful stuff.
So I couldn't hear that.
It's exciting to see how close it is to sort of doing the full thing.
I still have some problems with the sound. Yeah, sorry.
See if I've got my. Is that better?
Yes, if you have your head centered, so I don't know where you have the mic, but if you turn the head, I can hear nothing.
Oh no, I was just saying it's exciting to see that come along, and it looks like it's really coming together. That's neat.
Yes, thank you. I'm starting to looking for a new project.
I don't know if you could hear me before, but the memory, if you upgrade to a newer version, it should offer a larger amount of heap space by default. So.
Oh, that's great. That's great. How about the speed issue? I would really appreciate if we in Forth just could ask for high speed or low speed or whatever the word should be named, but I think it's tricky to change the speed otherwise if you only are a Forth programmer and not a C programmer or whatever. That would be really nice just to have a high speed or normal speed word.
Yeah, I put it on my list. I filed an issue in the tracker to look into it. It looks like it's not quite. There's the Arduino core apparently has some assumptions that cause it to be a little bit fussy about dynamically changing the speed, but it appears that folks have found workarounds. So I'll have to figure out what that is to offer some interface to it. I'll look into it.
Okay.